Good morning, everyone. Welcome to today's hearing. Today we're going to hear further expert evidence, this time from Dr. Barbara Lane. Yes, Ms. Grange.
Yes, could we call Dr. Lane, please?
Thank you. Good morning, Dr. Lane.
Morning.
You're going to take the oath, I think. Is that
Yes,
right?
I am, yeah.
There should be a testament on the table
Yeah.
in front of you. Would you take it in your right hand and read the words on the screen, please?
Yeah. I swear by Almighty God that the evidence I shall give shall be the truth, the whole truth, and nothing but the truth.
Thank you very much. Please sit down and make yourself comfortable. Right.
Yeah.
Off we go. Yes, Ms. Grange.
Yes, thank you. Yes, good morning, Dr. Lane. Thank you very much for returning to the inquiry to assist us with our work. It's very much appreciated. I will be asking you questions today. If you don't understand any of my questions, please just ask me to repeat them, or I'll put the point in a different way. And if you can also try and keep your voice up so that the transcriber sitting to your right can take a clear note of your evidence,
Yeah.
that would also be good. Now, if we can go to BLARP 25035, this is the report that you produced for the inquiry during Module 3, dated the 21st of May 2021, regarding the lobby smoke control system at Grenfell Tower. We'll just wait for that to come up.
Yes.
So there we have that. And if we go to the introduction at page 6, we can see that you explain at paragraph 1.1.3 that that was a supplemental report to Appendix J of your Phase 1 report, in which you presented your analysis of the requirements and provisions of the lobby smoke control system at Grenfell Tower.
Yes.
And then at paragraph 1.1.5, you say this Module 3 report retains the results of my Phase 1 investigations, but incorporates the findings I've made as a result of additional evidence available to me and my work in response to the investigations identified in my Phase 1 report. Is that right?
Yes.
And then if we just look at the final section of this report, we find that at BLARP 25035 at page 528, 528. There we can see a declaration and a statement of truth. Is that your signature?
Yes, it is.
Thank you. And you've also prepared a further supplemental report following receipt of Mr. Lay's report last summer. And if we could bring that up, that's at BLARP 25043. There's the supplemental report.
Yes, that's correct.
Yeah. And if we go on page 6 of this report to look at paragraph 1.14, we can see you've listed there your earlier work in relation to smoke control.
Yes.
And you tell us, if we go over the page, that this report concludes your analysis
Yes.
of smoke control. So there's the work that you've done on that.
Yes.
And if we go to section 11 of this supplemental report at page 266, there we see an expert declaration and a statement of truth. And if we go over the page on 267, is that your signature?
Yes, it is.
And we can see that the report there is dated the 14th of April 2022, yes?
Yes.
And you've also prepared an errata and corrections sheet, which for the transcript is at BLARP 25044. Now, have you provided your reports in the same way that you would provide a report to the court?
Yes, I have.
And can you confirm that the factual matters set out in your report are true to the best of your knowledge and belief?
Yes, I can.
And do your reports represent your true and complete professional opinion on the matters addressed within them?
Yes, they do.
Thank you. Now, I just want to start with some updating questions about your qualifications of background.
Yes.
We first asked you about those in Phase 1 in June and November 2018.
Yes.
So I'll take this reasonably swiftly. If we could bring up your addenda and errata, please, BLARP 25044. And I want to look at page 9 of this document. Is it right that, so what you've done here is just bring us up to date in terms of your professional memberships?
Well, actually, they were set out in my CV when I was giving evidence for the RRO, so I'm just reminding everybody of those dates.
Right, thank you.
Yeah.
So what we can see is that looking at section 1.2.3,
Yeah.
there under professional registration on the next page,
Yeah.
is that you were a chartered engineer via the Institution of Fire Engineers between 2001 and 2020, is that correct?
2002 and 2020.
I beg your pardon,
Yeah.
thank you. And then in 2020, you left the IFE and you became a member of Engineers Ireland in 2020 instead, is
That's
that correct?
Yeah.
And you transferred your chartered engineer registration under a mutual recognition agreement because engineers in Ireland have a mutual recognition agreement with the Engineering Council.
That's
is that correct?
Yeah.
Yeah. And you've held chartered engineer registration via Engineers Ireland since 2020. Is that correct?
Yes.
And do you remain a director of ARUP?
Oh, yes, I do.
Yes. Yeah. And what's your current role within ARUP?
My current role of ARUP is I'm an officer to the group board, and I'm responsible for what we call ARUP University. So that's the collective knowledge, learning, skills, research and innovation programmes for the global company. I'm responsible for things, for example, learning programmes for 17,000 people to help improve and maintain our collective expertise because of the type of work we do and the complex problems that we're asked to solve. There's a whole array of duties there. I sit as an officer to the ARUP Group Board, and therefore I'm considered to be part of the senior leadership team of ARUP Group, the global company.
Great, thank you. Now, we know from your previous appearances as an expert to this inquiry that your specialism is in fire safety engineering in the built environment, including the design, construction, operational stages, and you have over 20 years' experience on matters such as the consideration of regulatory compliant fire safety design and construction solutions, the performance and testing for construction materials in fire, and the handover process, including cause and effect testing of fire safety systems, management duties and handover documentation. Is that right?
Yeah, that's correct. And that's something that I and others call total fire safety. And because I'm being asked today, I consider myself to be an expert very much in that field.
Thank you.
Yeah.
And for Module 1, you provided the inquiry with a CV, which we can find at BLARP 25015.
Yeah.
And if we look on page 4,
Yes. Yep.
we've got your CV there, and we can see your ARUP roles and education there. I'm not going to go through them again. We've covered them previously.
Yes.
At page 5 and onwards of this CV, you set out selected project experience in the second half of the page, including on page 7 for high-rise residential buildings. And you've given us some examples there. Now, in terms of smoke control systems, can you summarise your experience in the design, specifying, reviewing and commissioning of smoke control systems in high-rise residential buildings?
Yes, I can. So this CV was produced specifically for Module 1. You'll see that in my other CVs, I've picked other projects or other, because I try not to draw in my existing clients into the inquiry, so I tend to try and explain my experience a different way. So for smoke control only, I consider I've had 5 years working full-time on this inquiry and 20 years experience before that. And I've decided I can split my experience into 3 chunks as such. So the first third of my career was spent as a junior engineer working for others, carrying out simple and complex smoke control calculations, and working with mechanical engineers in ARUP and outside ARUP, dealing with fan selection and other issues associated with smoke control in different types of buildings, including high-rise residential buildings and other high-rise. The mid part of my career, and again, I can provide a full list of specific projects as needed. The mid part of my career, I spent then in that level of seniority being responsible for writing the performance requirements for all different types of smoke control systems, including in high-rise residential buildings, in that particular period of my career, so that's coming up to the mid-2000s, there was a lot of concern in Arab Fire about the standard of smoke control systems on the island of Britain, and particularly how the numerical modelling was or was not being done. And we had taken the decision to do numerical modelling on all our projects where possible. And because of quality concerns, I personally set up the fire and smoke modelling team in Arup in the UK, so that all our project analysis came through one expert team, and I was responsible for that. And that's actually how those persons were involved with the SEA. And then in the final third of my career, which was in the years preceding the fire, I have a very different type of experience. And that's because I worked on a very significant multidisciplinary project with Arup where things were a little bit tricky. And I had to become part of the leadership of a commissioning team of a myriad of really complex systems, including different types of smoke control systems, including lobby depressurization systems. And after that, I spent the majority of my career working in operational buildings or on construction sites, either witnessing or personally certifying the operational performance of systems in buildings.
Okay, thank you.
So that's my experience as I find it.
And within that experience, to what extent did you have any involvement with existing or what might be called legacy residential buildings?
I tend to be brought in to existing buildings to look at the condition or the defective condition of systems. And one of my last projects before I had to excuse myself from all projects was an estate of, I'm frantically trying to remember, it was either 12 or 14 high-rise residential buildings with faulty smoke control system to protect the stair and to protect the extended travel distance in the lobby. And that building's currently occupied, so I don't want to give you the name here in public. Yeah.
Okay, that's fine. Do you have any formal qualifications in terms of smoke control?
Yeah, actually, I was thinking about that. I heard you ask Mr. Lay that yesterday. So I need to now explain to you the kind of degree I have, which is an engineering degree from Trinity College Dublin. And I didn't appreciate it at the time, but it's actually a very unusual and in-depth degree because you don't specialise in any one field of engineering until your final year. So for the first 2, if not 3 years, I had to study fluid dynamics, thermodynamics, combustion, heat transfer, and I sat a degree in mathematics in my 3rd year. And then in my 4th year, I specialised particularly in structural mechanics.
Thank you.
I just think I should continue because I know people are a little bit worried about my experience. When I finished my degree, I then carried out the experiments for Professor Drysdale's seminal work on the flashover compartment fires and the behaviour of the products of combustion in well-ventilated and under-ventilated compartments. And it's because of all of that experience coupled with my PhD, which was about the effect of fire on structural systems, that I was offered a job at Arup.
Okay, thank you. Now, have you yourself ever actually designed a smoke control system, or have you always been part of a wider project team that's been involved in?
So let us be clear what we mean by design. So as a fire safety professional, I am obliged to set the performance requirements from concept up to detailed design, depending on your obviously your contract. I'm responsible for those performance requirements, and I consider that to be design. I know some fire engineers don't consider that to be design, but I vehemently disagree. When it comes to doing detailed drawings, controls, equipment, scheduling of components, etc., I absolutely don't do anything like that, and it falls into the experience of different professional people.
And for a mechanical smoke control system,
Yes.
what kind of professions would then typically be involved?
Okay, well, I'm used to working with a mechanical engineer during design, if I'm lucky, because again, it depends on the contract you have, okay? But where you can get really, really involved, I would be working with the mechanical engineer, I might be working with the architect, and then hopefully I would get to work with the contractor and their respective teams, okay? Yeah.
Yeah,
That's
okay,
for the
thank you.
design phase, yeah.
Now
Oh,
we're gonna-
sorry, excuse me.
Sorry.
I also have to work with the statutory authorities and any other parties who have an interest in why I'm relying on that smoke control system in the particular project I'm responsible for.
Okay, thank you. And now we'll come on to some more detailed questions about the design of the system at Grenfell Tower, but just help us with this at this stage.
Yeah.
Have you ever come across a system which was similar to that which was installed at Grenfell Tower?
So do you mean a lobby depressurisation system?
In essence, yes.
Yes, I have, and I have personally worked on projects with them. And I got we have a project records team at Arup, and I wanted to work out the percentage of the different types of system we tend to offer on our projects. And lobby depressurisation systems take up over 1/3 of the designs we offer to people.
Yeah, thank you. Now, before we turn to some more specifics about the Grenfell Tower smoke control system, I want to begin by asking you about the regulatory requirements which the system needed to meet. Now, you've explained these in Chapter 2 and onwards of your Module 3 report, and in some detail as well in your supplemental report. Would you agree that in simple terms, if one is making changes to a building which do have to comply with the building regulations, the changes must either achieve compliance with the functional requirements in Schedule 1 or result in the building being no more unsatisfactory in relation to those functional requirements than it was before the changes?
In relation to those functional requirements, yes.
Yeah. Now, can we agree that the functional requirements which were relevant to the smoke control system at Grenfell Tower were B1, means of warning and escape, B5, facilities for the fire service, access and facilities for the fire service, but also B3 on internal compartmentation?
Yes.
Thank you. Now, in section 2 of your supplemental report, you discuss some of your disagreements with Mr. Lay about the regulatory framework which was relevant to the smoke control system.
Yeah.
And I want to start by looking at Regulation 8 of the building regulations. If we could go to CLG 19897. And these are the building regulations 2010. And if we go to page 9, we can see Regulation 8. It's right at the bottom of that page. It's headed Limitation of on Requirements.
Yeah.
And it says there, parts A to D, so that would include B, F to K and P, except for certain paragraphs, of Schedule 1, shall not require anything to be done except for the purpose of securing reasonable standards of health and safety for persons in or about buildings and any others who may be affected by buildings or matters connected with buildings. Now, you deal with this in your supplemental report and you refer to it as a life safety requirement. Is that right?
Yes.
Yeah. And is it your understanding that this provision imports a separate reasonableness test as distinct from what we see in the functional requirements themselves, which building control will apply on projects where building work is covered by the regulations?
A separate test?
Yes, a separate reasonableness test or a separate test of latitude?
Oh, yeah. Well, I mean, if I'm understanding correctly, I'm not aware that there's multiple separate reasonablenesses as such. So in my mind, I've always assumed that B1 to B5 as written are, you know, I'm allowed to read them and understand that they are relevant to the life safety requirement. I'm not aware, and anyway, I presume this is actually a legal matter, but yeah, thank you. So I'm just really, so as a practitioner, I'm not aware that I have two reasonablenesses to deal with now. Okay?
Yeah.
So I read B1 to B5, the top line functional requirement, as emanating or inserting into this Regulation 8. I don't adopt two different tests in practice, if that's appropriate for me to say. Yeah.
Just putting it maybe a slightly different way, can we agree that the functional requirements themselves are often expressed in terms of reasonable standards of health and safety? So appropriate means of escape or reasonable facilities for the fire service, that's B1 and B5.
Oh, yes. Yeah. Well, I understand that's what the authors intended.
Yes.
Yeah.
So that there is some scope for building control bodies to decide what amounts to a reasonable standard of health and safety when they're looking at whether those functional requirements are met.
A reasonable. Yes. No, of course. Yeah.
Would you accept that what may be considered practical to achieve a reasonable standard of health and safety in a new building might differ from that which might be practical in a legacy or existing building?
Yeah, potentially. It depends on the circumstances of the case. It's not one blanket problem. Some existing buildings can be very easy to work in. Some new buildings are incredibly difficult to put together, active and passive fire protection measures that taken together can be easily proven to meet the functional requirements. So I probably should be absolutely clear that I don't at all agree that new buildings are easy and existing buildings are complicated. And certainly, I know I work in a company where people employ us because their building is so complex. So I have a lot of experience about those really challenging circumstances in new buildings when it can be very, very difficult to find a solution that I am satisfied can comply with the functional requirements.
Right.
But yes, some existing buildings are very, very difficult to work in.
Okay.
Yes.
Now, can we also look at Regulation 11 of the building regulations, which is over the page at page 10. This is the power to dispense with or relax requirements. And it refers back to the power contained in Section 8.1 of the Building Act 1984. And this makes clear that that power shall be exercisable by the local authority.
Yeah.
Now, you say in your report at paragraph 2.5.3 of your supplemental report, we don't need to bring it up, that in your experience it's extremely rare for a dispensation or relaxation of functional requirements B1 to B5 either to be sought or to be granted. Is that right?
Yes, that is my experience, but we should just be really clear of what we mean by requirement. So that's the top line, B1 English, and I have no experience of someone going in and saying, I'm not planning on complying with the functional requirement B1. People do need to apply for, I don't want to miss dispensation or relaxation, about one of the provisions within that requirement, not the requirement in full itself. That's what I mean. And it's a very common misconception in the profession that obtaining a relaxation or a dispensation for a component of that isn't intended to meet the functional requirements is a relaxation of the whole requirement in itself. A very common misconception.
I see. So have you ever come across any situation in which a building control body did dispense or relax a requirement for an entire functional requirement?
Absolutely not. Yeah. No.
Mr. Lay explained yesterday that the combination of these two regulations, Regulation 8 and 11, effectively meant that there was he called it a climate of latitude amongst building control bodies. It gave building control some discretion, some flexibility in terms of the way they required the functional requirements to be met. Now, have you come across that in your own experience?
Okay, but sorry, because I have to be really, really specific now because of where we are. You said both climate and 8 and 11 read properly allows that, and they're two very different things.
Okay.
So do you want me to give a view on both?
Let's take them separately. Have you come across a climate of latitude or a flexibility on the part of building control bodies to effectively do what they consider is reasonable in the circumstances, and which allows a great deal of flexibility in the way the functional requirements are interpreted?
I don't want to single out building control here, but it is absolutely clear, it was absolutely clear before this fire, and I think you don't need expert evidence since the fire, that there was a climate of, you know, I just worried about what word to use here, you know, a climate of worrying standards, okay? That can't be attributed solely to building control. In the context of Regulation 8 and Regulation 11, it is not my understanding, okay, and I'm not sure I've ever heard a building control body say to me, I've taken 8 and 11 together and on that basis I have the following opinion. I've never heard someone say that to me.
Okay.
I don't know if that's answered your question, but I think climate and then the facts around the regulations are two very different things.
Yes. Have you seen any evidence in relation to all the smoke control documentation you've looked at on Grenfell Tower that there was any dispensation or relaxation under Regulation 11 considered by building control in this project?
Well, not that I've read about.
Yeah.
Yeah.
Now, another area where you've expressed some disagreement with Mr. Lay is about documentation. We saw, and I put it to him yesterday, that at paragraph 8 of his report and paragraph 875, he says there's no requirement in the Building Act or the regulations for persons to document how they achieve compliance. Now, in fairness to him yesterday, when pressed on this, he was saying, well, what I'm saying is it doesn't tell you the extent of documentation that you need to achieve compliance. And potentially, you know, there would be a varying amount of documentation that you would need. Now, let's just take the simple point first. Is it your understanding that there is a duty on the part of those carrying out the works to show how they are going to comply with the building regulations?
Yes, I do think it's a duty.
Yeah. And is that because of, I think you say this in your report, Regulation 14 in particular, the full plans application regulation in the building regulations? Yes,
and other duties designers have under different pieces of legislation. The onus is solely on us, and it's I've already spoken about this several times, about the responsibility of designers to demonstrate with transparency and with, you know, knowingly communicate the meaning of what they're doing and the significance of it. And I don't support at all the quite prevailing opinion that if someone doesn't notice, you've done a good job.
Right.
Or discharged your duty satisfactorily.
Right.
I think, and my understanding also, and certainly how we comport ourselves, is in the event of something, you know, either legally or, you know, some incident, the onus will be on me as the designer, not a member of the building control body. Particularly, it would be on me as a designer, to be able to demonstrate how I transparently and honestly and knowingly explained why, what I was offering, why, and what it can do in the event of a fire. And that includes when I know it won't be able to mitigate certain circumstances that a building control body might reasonably, intrinsically expect.
Right, I see.
Okay.
Thank you. Now, I also want to discuss with you Regulation 4 of the building regulations, which you've dealt with in particular in your supplemental report. And if we go to that supplemental report at BLARP 2, 5043, page 65, if we look at 4.1.3, here you've cited Regulation 4.3. So there it says building work shall be carried out so that after it's been completed, and any building which is extended or to which a material alteration is made, or any building in connection with a controlled service or fitting is provided, extended or materially altered, or any controlled service or fitting complies with the applicable requirements of Schedule 1, or where it did not comply with any such requirement, is no more unsatisfactory in relation to that requirement than before the work was carried out.
Yeah.
Yes, and I asked you briefly about this. So this is the no more unsatisfactory position, and that's often referred to as the non-worsening principle. Is that right?
Yeah, it is. Sorry, can I just say something here as well? So we, like in the inquiry and everywhere else, everybody always focuses on the no more unsatisfactory, but actually it's no more unsatisfactory in relation to that requirement. It's not no more unsatisfactory. And I think the additional words after unsatisfactory are actually extremely important in terms of certainly how I read that regulation.
So I think what you're saying is,
Yeah.
and I think Mr. Lay agreed, you should read it like this, that it's no more unsatisfactory in relation to that functional requirement than before the work was carried out.
Exactly. It's not just generally, and that again is a slightly prevailing culture in industry, that if it's generally slightly better, you know, the job is done. And long before this inquiry, you know, I have never shared that. I don't believe that's how that regulation was written, but it's not for me to say. It's just how I read it in practice.
Now, in terms of non-worsening, Beryl Menzies, the inquiry's building control expert, explained in her evidence that she thought the appropriate comparator for building control would be the existing system in its working state, or at least how you believed it would work. That was her evidence. Do you agree with that?
You know, when you say believed how it worked,
yes,
my belief might be.
Well,
you know,
leave that to one side.
Okay, so
and just focus on. Do you agree with her that the appropriate comparator for building control, if taking a non-worsening approach or a no more unsatisfactory approach, she felt would be the existing system, so the existing smoke control system, but as it was meant to work, in its working state.
Exactly, as it was intended to function at that time. Yes. Yeah.
And Ms. Menzies also explained in her oral evidence that when assessing whether the building is no less compliant, the requirements of the regulations to which the altered building must be no less compliant are always the current functional requirements of the building regulations, so B1 to B5, and not whatever requirements were or may have been in place at the time of original construction.
Oh, yeah, sorry, I'm sorry. Can you just repeat that again? Sorry,
I think the point she was making in relation to the wording that you've just emphasised is no more unsatisfactory in relation to that requirement.
Yeah.
The point she made is that you're looking at it through the prism of the current functional requirements as opposed to any functional requirements that might have applied back when the building was first constructed, if they were different.
If they were different?
Yes. That was her evidence.
Okay. And you're asking me if I agree with that?
Yes.
So I'm trying to frantically remember if the functional requirements had changed. I'd have to go back in and look at my report. My understanding is that it's the functional requirements at the time I need to understand, and so what the system was intended to do at that time. And then I'm considering it also through this prism you described to try and work out the situation I find myself in, I suppose, or if there's a gap between what's required now and what was required back then, I think is maybe what you're trying to ask me.
Ms. Grace, this is really a matter for construction of the regulations, isn't it?
Yes, I think it is.
Yeah.
But these are some questions that have been submitted, and I'm trying to explore what Dr. Lane's understanding is as a practitioner in this area.
So exactly, because that's a really complicated question. I am uneasy answering it. So in terms of working on one of my projects, I will look at the functional requirements at the time, understand what the designer needed to produce. I'll look at the functional requirements now, understand what, as a designer, I need to produce, and I will establish whether or not there is a gap between those two things or not.
Yeah, that's helpful.
That's about all I can say.
Yeah, that's helpful. Thank you. Now, you've suggested in your report that this non-worsening approach requires a comparison to be made between the performance objectives of the original system and those of the new system. Is that correct?
Yeah. Yes.
Do you agree that there's no express reference to any such comparison with performance objectives within the wording of Regulation 4.3 itself?
I absolutely recognise that, but there's no other way to carry out the comparison I've just described to you.
Right, thank you. Now, Let's just move on to start thinking about the smoke control system at Grenfell Tower and the background to this. I just want to start with something from Mr. Colin Todd's report. If we could go to CTAR 701 and look at page 64. This was the report he prepared for phase 1 of the inquiry's work. And at 64, paragraphs 5.2.42, little 4. So it's in the middle of that page, it's the little Roman 4, beginning guidance on. Do you have that? So he says this: guidance on the provisions for smoke control in the common parts of blocks of flats was changed within the 2006 edition of ADB. See paragraph 2.26. The previous philosophy in relation to this matter was reversed. Previously, the objective of smoke control in the common lobbies of a tower block was deemed to be the dispersal of smoke within the lobbies, while, as something of a, quotes, bonus, the smoke control would also afford protection to the common stairway. The philosophy described in the 2006 edition of ADB was that the means of ventilating the common lobbies was to protect the common stairway, so supplementing the protection provided by the fire doors to the stairway. It was now noted as something of an aside that the ventilation also afforded some protection to the lobbies. Now, do you agree with that basic summary of this shift in philosophy that we see in the approved documents over time? So an emphasis on smoke dispersal historically and protection of the common lobby, with some bonus protection to the stairway, effectively flipping over to being protection of the common stairway being the primary goal, with protection of the lobby being something of an aside. Do you agree with that?
I like, it depends on, so I can't, I understand the sentiment of the paragraph, okay? But when the smoke dispersal systems existed, I really think, I thought I put this in my report, there was still some ventilation provision made to the stair, okay? It wasn't without any consideration. And this switch then, the philosophy of the ventilating the common lobbies was to protect the common stairway. So that's that depends on the travel distance.
Right.
So it's not all the cases.
Can I just butt in here? I think what Mr. Todd is suggesting is that there was a switch from making the protection of the lobby the primary consideration.
Yes.
With a potential benefit to the stairs, to making the protection of the stairs the primary consideration, and the protection of the lobby or the benefit to the lobby being adventitious.
Understood, but it's not for all travel distances. That's the problem. So there's a body of buildings where that's correct, because the travel distance is within a limited distance. And then there's a body of buildings where the protection to the lobby remained a relevant parameter for not just for protecting the staircase. Apologies. Okay, so remember the dispersal systems it's expressly stated in the CP3 standard, and I think I've pasted that in to the supplemental report. It expressly stated the system was to, extend the travel distance in the lobby. So the philosophical shift occurred, but it's not in all cases, okay? So it's a little bit more nuanced, but that is true in many cases.
Thank you. Yeah, that's helpful. If we could just look at paragraph 2.25 of ADB, if we bring that up, CLG 50224 at page 30. That's ADB. It's the version that would have been in force when the refurbishment works were carried out. And if we could look at 2.25, in the right-hand column, smoke control of common escape routes, it says, despite the provisions described in this approved document, it's probable that some smoke will get into a common corridor or lobby from a fire in a flat, if only because the entrance door will be opened when the occupants escape. Do you see that?
Yes.
Now, does it therefore follow that one would not expect the lobby to be completely or even largely smoke-free throughout the course of a fire in an adjacent flat, even if the smoke control operated exactly as it was intended to?
That's a very big, all-encompassing question. So you're asking me if the lobby remains fully smoke-free, what did you say, or there will be some smoke in the lobby, even if a smoke control system designed to protect what is operating?
Well, I suppose that's a potential caveat to the question. But, I mean, let's assume there's a travel distance of no more than 7.5 metres.
Yeah.
So we're not into an extended travel distance situation.
Yeah.
Is it the case, though, that you still wouldn't expect the lobby to be completely
clear? No, it's
clear
not.
of
It's not.
smoke?
No, it's not physically possible. And what you're trying to do is minimise the time period where that condition is underway.
Yes, I see. Yeah. So the presence of some smoke within a common lobby in the course of a fire would not of itself constitute evidence that the smoke control system was not operating as it ought to.
Yeah, I'm sorry, I can't. I think that question is too large for me to give a yes or no answer, because there's so many different scenarios. I'm afraid to give a yes or no answer to that question.
I see. Is that because
it's kind of, you know, I can't say if there's some smoke, it doesn't mean the system has failed. It's not one parameter or the other.
Yeah.
I understand that the let's say, to say the question in the positive, that when a smoke control system operates satisfactorily, there will be some smoke in the lobby. Yes, I can't do it in the reverse because it can be misconstrued.
Okay, that's helpful.
Yeah.
Now let's just think back to the original system design of the smoke control system at Grenfell Tower when it was built.
Yeah.
We can see a diagram of that in your phase 1 presentation. If we go to BLA 405481, page 173. And sorry, we need to rotate this diagram. So this is the diagram that you came up with when you first did a presentation a long time ago now into this system.
Yeah.
And Mr. Marnie said at paragraph 18 of his second witness statement that this existing system was a natural ventilation system with a mechanical boost function.
Yes.
Now, do you agree with that?
Yes, I do. Yes, I do, based on my reading of Max Fordham documents.
Right.
Yes.
Thank you.
Yeah.
So its first level of operation would be just as a natural system.
Yes. Yes.
So if there was a fire in a flat on a particular floor, you would expect naturally there to be some airflow coming up the south shaft, passing through the lobby, and then discharging some smoke up the north shaft. Is that correct?
Okay. So the south shaft acting as an air inlet was, as I understand things, for when the system was in mechanical mode.
I see.
Yeah.
Okay. So before the system was in mechanical mode, before any fans were activated by the fire brigade, what was the system designed to do in the event of a fire?
Yeah, it was a smoke dispersal system, so to naturally ventilate the lobby.
Right. And can you just give us your definition of a smoke dispersal system? What do you mean by a smoke dispersal system?
The smoke flows under its own... I was about to say capability, but that's wrong. The smoke, as a function of the smoke produced from the specific fire, it should flow towards the... the extract points on that lobby. Yeah. So that was intended, to provide some protection to the lobby, was it? As I read CP3 1971, that's what it intended, yes.
Right. And then once the fire brigade arrived, it had a mechanical mode, is that correct?
Yes, if they chose, they were given a switch downstairs to... I had understood to start a fan at the roof and start the fan, I think it was down at level 3, if you read the Max Fordham documents. So you had mechanical inlet and mechanical outlet.
Right.
That's Yeah.
Yeah. Mr. Marnie, when he gave oral evidence to the inquiry, said he'd been told that the original system didn't have a supply fan at low south level and only an extract fan in the north shaft of the top of the building. Are you able to help us with whether that's consistent with the documents you've read?
No, I mean, I have the Max Fordham documents, and that's what they say. I'm assuming they had checked for themselves.
That there was a fan at level 3?
Yeah. I know that Mr. Hanson did query in the very early discussions, he asked that question. That's all that I know.
Right. Yeah. Okay, thank you. Now, in summary, is it your view that the guidance which appears to have been used when Grenfell Tower was first designed and built, i.e. CP3 1971, included as performance objectives, first of all, the protection of common lobbies for means of escape, second, the protection of the stair for means of escape, and third, the protection to firefighters when using the common lobbies?
Yes. Yes.
I think you set that out in your supplemental report. For the transcript, that's at BLARP 2, 5043, pages 71 and 72. Now, do you consider that all of those performance objectives were met by the original system, even though we know that it didn't comply with all of the guidance in CP3 1971, including, most importantly, the shaft sizes were much smaller than recommended in that guidance. So they were only 0.48 metres squared instead of 1.5 metres squared.
So you're asking me if I know the system performed to the functional requirement at the time, despite its design. Is that the question?
Yes.
I have to assume that it did. How would I particularly know? I don't know. Is there deeper context to the question?
No, I think the point that's being made is it's all well and good to say, well, CP3 1971 has those 3 objectives.
Oh, yes, okay.
But this seems to be a system which didn't actually meet those objectives. Well, sorry, this is a system which didn't meet all of the CP3 guidance because it didn't have 1.5 metres squared vents.
Okay.
So could it have been a system which was deliberately designed, perhaps not to meet all 3 of those requirements, but which building control nevertheless thought was satisfactory? That's the point that's being made.
All of that is kind of speculation as far as I'm concerned. I did read, I thought Miss Menzies was quite clear on this actually, and I'm sure she was very clear on this, and I am happy to assume that at the time the dimensions, the components, and it was kind of slightly new engineering system at the time. I'm assuming it was deemed to comply with the building regulations because it met those functions.
And does that mean that you think it's reasonable to assume that a performance objective would have included protection of the common lobby for means of escape?
At that time?
Yes.
Yes, I do, because of the travel distances, and it was very clear at that time.
Right.
Yes.
And is what you're saying that CP371, one of the new things it was doing was allowing extended travel distances in certain circumstances?
Yeah, it says that. It says it at the start of the document.
Right.
Yeah.
Yeah. Now, is it possible for anybody to tell, in fact, what level of performance the existing system would have had when working?
If one did a computational fluid dynamics model of it.
Right, okay. And how easy would that have been to have done at Grenfell Tower? Could one have done that?
Yes.
Right, yeah. So you could have taken the existing system, the capacity of the fans, the size of the shafts, etc.
Yeah.
And done a calculation to look at the performance of the existing system, could you?
If that information was available, yes.
Right.
Yes.
And so just to be clear, is it your understanding that that existing system would have provided protection to the lobby, in fact, would have actually provided some protection?
No, but I can't like that. I can't. You're asking me to guarantee something. I'm sorry. I don't want to sound disrespectful. How on earth can I do that? It should have protected the lobby. I can't tell you that it would or did every time. No one can answer that question at the moment. So it should have protected the lobby with the travel distances it had.
And when you say protect the lobby, what do you mean exactly? Because you agree that there's going to be some smoke in the lobby, or likely to be.
Well, okay, so again, we're all postulating now in all different kind of scenarios. So it should have protected the lobby, so there were tenable enough conditions to escape. Okay, there's no suggestion by me or anyone that any system produces this beautiful, it's a perception people have, this, you know, something like this beautifully clear space. That's not what happens in a real fire. You don't need me to tell you that.
Okay. Turning then to the system that was actually installed at Grenfell Tower, I just want to look at that.
The new, are we in the new?
The new system.
Sorry, okay.
Let's look at your Module 3 report. This is BLARP 25035 at page 260. And here, if we blow this up, it's quite an intricate diagram, but if we could blow it up so we can try and see it as clearly as possible. This is an illustration of the new smoke control system and how it was meant to operate. Unlike the old system, is this right? Instead, what we got was an extraction of air or smoke at the low level, the south level.
Yes.
And continuing to have an extraction up the north shaft.
Yes.
So instead of it being a kind of what's been described as a push-pull, we're getting a pull-pull. Is that a fair way of summarising?
Yeah.
And can you just help us, in general terms, what kind of system this new system was? How would you describe it?
Do you mean outside as I've described it in my report?
Well, I'll tell you what, I'll come to some more specific questions.
I called it a lobby depressurisation system since April 2018, if you go back and check.
Yeah.
And then in my Module 3 report, I thought I'd better use the phrase Mr. Mahoney used, or Mahoney, sorry. But they mean the same thing.
Right, yeah. And is the primary purpose of this system, as you understand it, to extract smoke from the lobby?
Not as PSB designed it, no.
Right. Because that appeared to be the thrust of Mr. Marnie's oral evidence, that the key performance criterion was the extraction rate of 3 cubic metres per second from the lobby, through the stair door, which was delivered by extracting through the north and south shafts.
Okay. I understand the purpose of the system to be to produce an airflow through the open stair door in a particular condition.
Yes. Now, had you been designing this system or considering the design of this system, would you have had any concerns about relying on the existing location of the south shaft dampers for extracting smoke, given that they were low to the floor? We saw a photograph of this yesterday. In each lobby, the south shaft vents are low on the floor and the north shaft vents are higher up on the floor.
Yeah.
Would you have had concerns about extracting smoke from low level within each lobby?
Yeah. Well, I would have noted that it was unusual, and I don't really like doing this. I would have stuff, but we would have done a numerical model anyway, and certainly with one or two of the more complex aspects in that lobby, I would have been more at ease about, say, satisfying myself about the location of those points down near the floor through numerical analysis.
Right. You said it was unusual. How unusual is it to have vents which are extracting from a lobby like that at low level rather than higher?
Well, it's very unusual because the idea is you're extracting the smoke up at high level whilst it's hot to try and maintain a safe walking space underneath it.
Right.
Obviously, I am aware of projects in the world where people have attempted to extract downwards, and it's a very tricky matter indeed.
Well, that's a slightly different point that I want to come on to. What about the extraction of smoke downwards through the south shaft.
Yeah.
So unlike the north shaft where you've got, natural buoyancy or stack effect, whatever, various forces which might help in that north shaft, would you have had concerns about the, in principle, approach of trying to extract smoke downwards?
Well, I think it sounds extreme saying kind of concern. So it's another parameter that's making this system. So as a designer, it's another, if the designer has made that decision, as a fire engineer, it's another parameter I need to be very sure about, and that the consequences of it have been factored into the wider design requirements. Okay, so like all engineers, I'd be up for the challenge, okay, but to satisfy yourself about, the slightly unusual case here, in my mind, you have to do a bit more work to make sure it's not causing something that you may not expect, for example, or you may not have seen before.
Right. Can I just ask you this? If you approach the new system on the basis that the primary objective is to create an airflow through the stair door, the fact that the south ducting and the vents are near the floor isn't going to matter for that purpose, is it? But what it will mean is you don't get the concomitant benefit of smoke dispersal or reduction.
Yes, but also, so correct, okay? But the other issue is to do with fan selection, okay? And I don't want to stray, I've been very clear, I don't want to stray too far outside here, but picking a fan has to then incorporate all the different things that resist, that cause resistance to the performance of that fan. And that is why you need to satisfy yourself that route, the convoluted route, or not the damper area and location. Sure. So you could say it's almost a if you wanted to imagine it, it's a non-smoke layer problem, because you're not trying to maintain a smoke layer, but it contributes. I mean, from my perspective, smoke control systems have so many different parameters that have to be balanced, and some of the parameters have a negative effect on each other. That's why I think they're actually quite difficult myself in practice. And so the smoke layer point you make, I agree with, but it has other consequences in the round when trying to get this system to have all the components that fundamentally will be balanced, okay?
I see that. I mean, I raised the point only because it was inherent in some of Ms. Grange's questions that it might be questionable to seek to extract smoke from low-level vents. But if you're not setting out principally to extract smoke, that doesn't seem to matter much. But you won't get the same benefit as you will from extracting from a higher level, presumably.
So again, you see, then you have to get into why you're extracting the smoke. And are you trying to maintain a clear layer, and on it goes. So
isn't that, I'm sorry to interrupt. My understanding is that the primary purpose of this system is not to extract smoke, is to create a flow through the stair door, and therefore extracting smoke is a sort of secondary benefit. It's
a secondary benefit, but I suppose what you also have to try and make sure that you're not doing is causing, so if you're doing your numerical model, you might see that this is just a conceptual opinion from me. I have not done any I haven't done a CFD model. You may cause a condition in the lobby that wouldn't occur if the vents were at roof level, and you need to satisfy yourself again. You're not causing a hazard that wouldn't have existed in another system, and whether or not that matters.
I see.
It may not matter at all.
Thank you.
Thank you. If we could go within your supplementary report, please, BLARP 2 5043 at page 50. Now, in section 3.5 of your supplemental report, you've discussed the different types of smoke ventilation system available since 2011 and their recommended performance objectives. And if we go on within this at page 53, at table 3.2, what you've done, and it's a detailed piece of work, is you've summarise the performance objectives of different types of systems.
Yeah.
Does that make sense? So you've got a type of system down the left.
Yeah.
Is the type of system intended to provide protection to the staircase during means of escape? Yes or no? Is the travel distance less than or equal to 7.5 metres? And because at the top you've asked, is the system intended to provide protection to the lobby in addition to providing protection to the staircase during means of escape phase? Yes? And you've derived these objectives from statutory and other guidance, is that right?
Yes.
For example, from ADB or BS 999. Now, if we go to page 55, you set out some conclusions from this analysis. And what you say is this, so as derived through this table, it's at the top of the page, the performance objectives of a smoke dispersal system designed in accordance with CP 371 is to enable extended travel distances of up to 15 metres in the common lobby by providing protection to the lobby and staircase for both means of escape and firefighting phases. B, all the various types of system can be designed to provide protection to the staircase during the means of escape and firefighting phases. C, no published guidance specifically recommends the use of either a natural system or a pressure differential system to protect the common lobby where the travel distance is greater than 7.5 metres. And you've quoted the SCA Guide 2015, which states that generally natural ventilation is not appropriate for corridors of this length, so the system provided should be mechanical. On that basis, these systems are unlikely to fulfil the performance objectives of the original system. And then you go on and you say BS 999 from 2011 and 2015, and both SCA guides recommend a mechanical smoke ventilation system when protection is required to both the common lobby and the staircase during the means of escape phase where the travel distance is greater than 7.5 metres, i.e. meeting the performance objectives of the original system installed at Grenfell Tower. So, sorry for that slightly long, but that's a useful way of summarising your analysis. Now, you've told us in your reports that you consider that the system which was eventually installed at Grenfell Tower was most akin to what's called a mechanical extract-only system, as described in the 2015 SCA Guide. If we could just look at that. This is at RBK 402932. If we go to page 37. At section 6.4.4, it's got a heading from...
Is 2012, is that? Sorry, I didn't see the front page.
No, this is the 2015 guide. Okay. Sorry. This is a mechanical extract only description. And in briefly, can you just explain why, because there's a difference between you and Mr. Lay here. Mr. Lay says that the description that most accurately meets this system is a mechanical extract natural inlet system, whereas you say that actually it's a mechanical extract only system. Can you just explain why you say that?
No, well, actually, what I said was, I'm not sure where in my report you are. I said that when the door is closed, it's a mechanical extract only system, and when the door is open, the natural inlet comes through the open stair door. So, and I set all of that out in, anyway, it's both.
Right, I see. Now, in your report, let's go to that. It's BLARP 2 5043 at page 41. At paragraph 3.3.17 of this report, you refer to a specific warning in the SCA guide regarding mechanical extract-only systems. And you say there, the SCA Guide 2015 makes the following point. Mechanical extract-only systems using natural leakage for replacement air are not suitable where extended travel distances occur unless specific consideration of the risks is undertaken by the designer and approval obtained from the authority having jurisdiction. Yes. And you say the significance of this is that the SCA Guide 2012 stated mechanical systems, as described in Section 6.4, may be designed to allow extended travel distances subject to agreement from the approving authorities. So you're picking up on a difference between the two SCA guides.
Yeah, well, I'm trying to, so that's correct, but also it's about having a dedicated supply of inlet air in any condition.
Yeah.
And when you don't have a dedicated supply of inlet air in certain conditions.
Yeah.
Okay.
Now, can you help us as to, do you know on what basis this warning was added for these specific systems in the SCA Guide 2015?
I have no idea.
You don't know?
Well, I'm not
No.
in the SCA, so
No,
I
I
can't
appreciate
answer that question. Yeah.
But do you have any idea what
No,
might
I don't
have...
have any ideas because I'm not in the SCA and I don't know anything about it. Yeah.
Okay, so you can't help us as to why they might have said...
No.
that mechanical extract-only systems using natural leakage are not suitable where extended travel distances occur.
I can't factually explain why they put that into their guidance document.
Okay, thank you.
But I'm sure it's clear from my report and all the other reports on this subject about how smoke behaves when doors are closed.
Right.
Okay, but I don't know what the SCA were doing.
Now, in terms of the design basis for the PSB design, if we could go back to your Module 3 report, BLARP 25035, and look at page 32. At paragraph 2.5.1, you basically say that proposing an alternative solution to the provisions made in ADB 2013 such that it meets the functional requirements is termed an alternative approach. And then at 2.54, you say certain relevant characteristics of Grenfell Tower were pre-existing and did not follow the guidance within ADB 2013. In particular, A, the position of the dry fire main, which was in the lobby and not the stair, and B, the travel distance in the lobby was, you've measured it at 10.5 metres and therefore extended beyond the limit in ADB of 7.5 metres. Is that right? So you're drawing attention to the fact that there were certain unusual characteristics of Grenfell Tower which were part of its existing situation. Is that correct?
Well, I didn't say they were unusual.
Sorry, that was my word.
Okay.
Sorry.
Yeah. They're just that's just the conditions.
Yeah. Now, was another relevant pre-existing characteristic of Grenfell Tower that meant that it was difficult to follow, for example, the guidance in approved document B, the small size of the builder's work shafts that went through the core of the building?
Sorry, so will you say that again? Sorry.
Was another relevant characteristic of Grenfell Tower the fact that it had these small existing shafts that were part of the original system?
In what context? I mean, they were a known constraint. Is that what you're asking me?
Yes, I think that's the point that's being made, that they were another known constraint on the
and
system.
I've been clear. I mean, I'm not able to tell which report this is from the screen, but I've been clear in my supplemental report because I was asked to be clear about constraints.
Yes.
Yeah. So yes, the builder's work shafts were of fixed size.
Right, yeah. Would you agree with this, that in the majority of cases, smoke control systems in high-rise buildings are bespoke solutions which have to be tailored to the particular existing conditions of the building?
Yes.
Now, if we go to section 3.6 of your supplemental report, BLARP 25043, and look at page 56, in this part of your report, you've considered the project constraints as they were at the time of the primary refurbishment. Is that right? That's the title.
The documents containing the constraints.
Yeah,
Yes.
yeah. So you've had a look at what were the project constraints as evidenced by the primary documents.
Yes.
And we can see these, you've set these out at table 3.4 on page 57. And these included the requirement to I want to look at the left-hand column, the requirement to reuse the existing smoke exhaust shafts, which came from the employer's requirements, yes?
Yeah, yes, yeah. Well, there's different description across under each document.
Yes.
Yeah.
And then over to page 58, you also refer to reusing the existing damper openings, but you suggest that this was not specifically stated in the employer's requirements. Now, is that something that you consider ought to have been explored? Or, yes, do you consider that you ought to have someone ought to have explored whether or not reusing the existing damper openings was a constraint, or whether something else could have been done with those openings?
If the area of the openings were relevant to the design I was trying to carry out at the time, and it was posing me a problem, yes, you would explore it. I think I've read that those openings were, like, to me, a constraint actually is almost contractual. They tend to come with, your constraints are imposed on you on a project. So that, yes, it should be explored if it's causing, a lowering of performance or a lowering of flexibility in what you might like to provide in that building.
Right. Now, in terms of other constraints, if we go over the page to page 59 and look at your paragraph 3.6.8, you say this. You say, I found no documentation directing the design team not to locate the new south shaft fan in the rooftop plant room. Do you see that?
Yes.
And you say at 3.6.9, I do not know from the evidence either why it was decided that the south shaft extract equipment would be provided at level 2 and not on the roof, nor why extending the south shaft to the roof level and placing the south shaft fan there instead was not either considered or the subject of a cost-benefit analysis. Now, first of all, what documentation would you have expected to have seen which gave consideration to whether the fans could be located at roof level? What type of analysis would you have expected?
Sorry, yeah, I'm just kind of slightly struggling to follow. So are you asking me what documents I would have expected the design team to put forward, or do you mean if the client was making it a constraint?
I think the former. What documentation would you have expected the design team to have put forward if they felt that that was a constraint?
I don't know. So I don't, like, I'm struggling to, do you mean the document type? I don't know really what you mean. So I can't be specific on what document type. I can say that I would, do you mean like a Word file with an analysis of, I don't really know what you're asking me.
Well, I tell you what, let me give you some examples.
I mean, just an analysis of why they may have needed to use the plant room, what might need to move. Is that what you're asking me?
Yes. I mean, how...
The consequences of the equipment being moved, how long that might cause temporary or, time problems with services not being available, if you could do it in phasing, or if fundamentally it caused such a, to do with time, movement of equipment and the consequences in an occupied building.
You would have expected that, would you, if they were going to conclude that they couldn't put the fans at the roof level?
If I was, so I would normally either be instructed that I cannot use a plant room, or where the decision falls to me, and I have been in this position, where the decision falls to you, you have to make a very careful decision if the consequences of not doing it are consequences you can accept as a designer. Is that a better way of putting it? So I have, in a certain circumstance, had to insist that a plant room was rearranged to accommodate a new fan, yes. Would I like to do that on every project I work on? Absolutely not. And my clients definitely wouldn't like me to do it, if that's what you're asking.
Right, I see.
Okay, but I don't think you can simply say it's not possible without having worked it out for that specific building.
Okay.
But I don't know really why you're asking me. Yeah,
well, I'd like to know, see if I understand where we are here. Are you saying this, that at some point in the design stage, someone should have said, or at least asked himself the question, wouldn't the new system work better if the extract fans were at the top of the building
Yes.
and then gone on to ask, could we put them up there?
Yes.
And if not, why not?
Yeah, exactly. Sorry, that's why I'm just trying to, and then I don't know, would you write that down? Would you, and can I just say that's perfectly common, normal behaviour on a project, small or large,
And then someone might have said it'll be too expensive, too disruptive.
Yeah, or no way am I paying for that.
Whatever.
Yeah, whatever. Right. And then an instruction will come from your client.
Yeah.
Or, then in other circumstances, if I thought in a different circumstance the risk to life was so high that the client had to understand by not considering this highly disruptive work, there were other consequences for them. They're the kind of conversations a fire engineer has to have sometimes.
Of course.
Okay?
Yeah, I understand. So look, what I want to do is look at some just 2 email communications that occurred on this project with you. And I think the purpose of taking you to these is to my main question will be, is that adequate consideration of using the plant room or not? Because I think the point's been made that, in fact, on the project, they did think about this. They did ask themselves the question.
Yeah.
So if we could go first to JSW 403580. So this is an email from David Bradbury to Simon Lawrence within Ryden, copying in Mr. Marnie. And the subject is Grenfell Tower AOV shaft to roof plant room. It's the 13th of February 2015. And Mr. Bradbury Mr. Bradbury's of JS Wright, I apologise. So it's from JS Wright to Simon Lawrence at Ryden.
Yeah.
And he says, Simon, further to our conversation and following site visit yesterday, it appears we will have an issue penetrating through to the rooftop plant room, and there are other concerning issues such as the asbestos ceilings, etc. Therefore, we would need to stay with the original plan of having one set of fans at the lower level and one set in the rooftop plant room. So that's the first email. And then if we go to the second email, this is at SEA 30012828. And this is an email from Simon Lawrence to Kevin Lamb and Ben Bailey of Harley, copying in a number of others. Subject AOV louvres within cladding. And what's being said here, hi Kevin, in the last design meeting we discussed louvres through the cladding panels for the AOV system. At that time we had some ideas about the AOV design which would have meant that we could vent the AOV fans through the roof. Unfortunately, because of structural issues, we can no longer do this. So we'll have to revert back to the original plan. I've attached several drawings indicating our intentions for you to incorporate within the cladding panel design above the curtain walling and entrance door. So the point's been made that here are 2 emails from the project which would suggest that consideration was being given to locating the fans at roof level on the south shaft. But it looks like considerations such as the asbestos ceilings and have to penetrate through into the plant room meant that it was considered too onerous to do that. Now, I appreciate it's a difficult question, but is that the kind of level of consideration you would have expected to have been given to that issue on site? Or would you have expected a more detailed analysis, a more comprehensive analysis? Would you have expected a cost-benefit analysis? Before that option was discounted.
So I can see these 2 emails and I understand that that's what people were speaking to each other about. I don't know what the structural issues are. I don't know where the asbestos ceilings are. I can't remember. There was a third point in the first email. Sorry. At the risk of making myself very unpopular or more unpopular, I am used to people telling me things, I think I'm just going to leave it. I think that's a very high level. I think this is between Ryden and in JS Wright, you said. Yeah.
So the first one was between Ryden and JS Wright. This one seems to be between Ryden and Harley.
Yeah. So look, I'll tell you what, I can't give you expert evidence on the basis of these 2 emails, but I note that they have spoken to each other about it. I can't see any detail that would allow me to understand if it was a correct assessment of the building or not, and I don't think it's for me to say.
Okay, thank you.
Okay.
Mr. Chairman, I think that's a good moment to break, if that's...
Yes, very well. Well, we'll take the morning break at that point.
Okay.
You know the drill. Please don't talk to anyone about your
Okay.
evidence while you're out of the room.
No problem.
25, I should have said 25 to 12.
Thank you.
Thank you very much. Would you ask Dr. Lane to come back in, please? Okay. All right, Dr. Lane, ready to go on?
Yeah, sorry, I was being a bit slow there. I'm really sorry. What I should have said was I've seen those emails, and then I would expect on the CDM risk register there would be a line item explaining what decision had been made and why, and how the hazard had been assessed and was deemed to be acceptable. Okay?
Yeah, okay, thank you.
Yes, it's great.
Yes, thank you. Now, in relation to design options which were discounted by Mr. Marnie of PSB,
Yeah.
I want to ask you whether, in your view, it was reasonable for him to discount the push-pull system as had been proposed by Max Fordham, i.e. replicating the original system, or the original mechanical part of the system, with a mechanical push-pull system. Now, when Mr. Marnie gave oral evidence, he raised a number of potential problems with a push-pull system, and I just want to list those out. He said that would include excessive pressure drop in the shafts, and he talked about, you know, the analogy of trying to get an old quart into a pint pot.
Yeah, are they coming up on the screen?
No, I'm just going to
okay,
summarise
I'm going to try and remember. Yeah.
So excessive pressure drop, velocity jets across the lobby, which would push smoke towards the stair.
Yes.
And he said that a push-pull system is much more suitable for a corridor system.
Yeah.
Given that you would get dead ends here with a push-pull, given the I shape of the lobbies.
Yeah.
Now, do you share his concerns about the possibility of putting a push-pull system into Grenfell Tower?
So I think is it Mahoney or Mahoney?
I thought it was Marnie.
And he said Marnie.
Mahoney. Yeah, okay. So I understand. So the parameters Mr. Mahoney raised are relevant for consideration. I didn't find there's no evidence available to me how he quantified those concerns, how he quantified those parameters, and if they would indeed occur in the I-shaped lobby at Grenfell Tower. But they were relevant parameters to consider. Okay.
Knowing what you know about the design process and how it evolved, would you have expected more consideration to have been given to a push-pull option at Grenfell Tower?
I think I think that I would have expected more consideration by Max Fordham, first of all. Sorry, no, I shouldn't have used the word consideration. I would expect more analysis to have been done to bring some surety to the situation that push-pull at Grenfell Tower was not a viable option in the first place, and that before it was discounted. Yes.
Yeah, and when you say you would expect more analysis to have been done, can you just give us an idea of what kind of analysis you're talking about?
Well, personally, I'm talking about a numerical model of Grenfell Tower, and that's what, you know, lots of people do that. That's been discussed at length yesterday as well.
Right.
Okay. Yeah. And then that kind of it kind of ends it ends any speculation or assumption that, you know, a system is absolutely off the table or not.
Right.
Yeah.
Yeah. Now, Mr. Lay, in his evidence yesterday, he said that if you're going to try and get a push-pull system to work, you would need bigger extraction rates for the system to be put in, and he said he doubted that would be achievable with this system. Do you agree with that?
He doubted it would be achievable with a push-pull system generally, or with the equipment installed in Grenfell Tower? Just generally?
I think my understanding is, in general, he doubted that it would be achievable to put a push-pull system into Grenfell Tower, which had the bigger extraction rates that you would need for the system to work effectively.
Yeah. I think that all of us would need to have done some numerical analysis to be definitive, and I think the bigger issue about push-pull is the direction the smoke travels. So, for example, when you think about flat 16, which we've been doing a lot in the last year, focusing in on what happened on the night, if you were, the north shaft dampers were used to extract the smoke there, flat 16 is in the perfect location for a so-called push-pull system. But if you take a different flat, the most remote flat from the north shaft, unless you'd done numerical analysis, you couldn't satisfy yourself what extent of hazard remained in that lobby as a function of how the smoke was behaving there, okay? But I think there was nothing intrinsically wrong with deciding to use a lobby depressurisation system, and I think that's been kind of forgotten about really in my work as I see it. But before discounting a push-pull system, which does offer better protection in certain circumstances, I think more analysis should have been done. But we have to always remember the shape of the lobby at Grenfell Tower is a H or an I, or whichever way you see it.
Yes.
Yeah. So I'm sympathetic there. Yeah.
Sorry, I'm wondering if you can help me with this. A push-pull system would have had as its primary object what? The clearance of smoke from the lobby.
It depends what you design it for. So sorry, I know.
Well, I'm putting that in the form of a question.
Oh right. Well, all systems draw smoke. Will have some smoke in the lobby, but you can design those systems. Okay, you scale them to deal with the lobby, or to deal with the tenable condition in the lobby or not. So it depends what you're trying to do.
Well, let me explain why I asked the question. It seemed to me that a system which involves putting air into the lobby would not be entirely consistent with a system whose object was to create a flow across the stair door.
It's not consistent. Sorry, do you mean a push-pull system does something different?
Yeah, a push-pull system, I could understand how that could be a smoke clearance from the lobby.
Oh, yeah, exactly, yes.
But it would not be consistent with the objective of providing any airflow from the stair.
Oh, sorry. Well, so then you'd write a different spec to the one that PSB put forward. Is that what you mean? So your parameters that you would offer for a push-pull system are different to those that are offered, if that's what you're asking me.
Not just different, but is the primary objective different?
Absolutely. Oh, sorry, completely missing the point again. Yeah. Yes, it is.
So if you start with the objective of protecting the stairs rather than the lobby, then a push-pull system doesn't sound to me as though it's an appropriate system.
Why not? Sorry.
Well, that's what I'm trying to understand.
I think I'm kind of slightly losing you here, but
well, because it seemed to me that
if it's stopping smoke flowing out into the staircase, isn't it doing something?
Well, it may be. It may be that if you can clear the lobby adequately,
yes, exactly,
you won't get smoke entering the stairs.
Yeah. Yes.
That didn't sound to me as though that was the objective.
So, sorry, a push-pull system can clear smoke from the lobby at a different time depending on how you design it, and can then be relied upon to keep the staircase clear and potentially have a tenable condition in the lobby at certain times.
So it was a viable alternative, so to speak, if the configuration would have allowed it.
Theoretically, that's why I said to you at the start, that's why we considered them. Remember I said, so when we're looking at our projects, they are a consideration, but they have to be viable in the circumstances of the case. Yeah.
All right, thank you.
Yeah.
Now, you've said in your report, in your supplemental report, that the problem that Mr. Marnie identified regarding pressure drop with a push-pull system could have potentially been dealt with by either a higher performance fan or increasing the size of the existing shafts, yes?
Yeah, because, yes.
And you found no evidence that a cost-benefit analysis of such options was done. You also make that point.
Yes.
Would you have expected a cost-benefit analysis to have been done of both using a higher performance fan and increasing the size of the existing shaft?
I'd prefer to have seen a detailed pressure drop calculations satisfying all the, replicating the physical condition of Grenfell Tower to know that the fan was sized correctly.
Right.
Yeah.
So is what you're saying, you take it in stages and you do the calculations first to see what the pressure drop is?
Yeah, you see what situation you're in. Yeah.
I see. Now, Mr. Lay has said in his report, if we could go to paragraph 22 on page 17, so LAY 701, page 17. If we go to page 17, paragraph 22. There we go. So I just want to read a little bit of 22 and then 23 to you. So in the last 3 lines of 22, he says, consequently, I consider that the system which focused on protecting the stair by using both shafts for mechanical extraction was the most appropriate design response. And at 23, he says, I've not been able to identify any appropriate smoke control system design capable of installation within the constraints of the tower, which could have explicitly addressed both the lobbies and the stair, maintaining tenable conditions in both at the same time. Now, do you agree with the first point? Do you agree that a system which focused on protecting the stair was the most appropriate design response at Grenfell Tower?
The most appropriate? In what sense? That there was no other choice and one couldn't think about.
Well, to be fair to Mr. Lay, let's read what it says in the beginning of that paragraph. He says there were significant constraints present at the tower, including most pertinently the need to avoid intrusive works and using the existing north and south shafts. We saw you noted that in your report, whose combined cross-sectional area was significantly less than that required for a compliant natural shaft system, and the fixed geometry of the common lobbies. So it's in that context, the constraints that we've been discussing, that he's saying that a system which focused on protecting the stair was the most appropriate design response.
But that's his opinion, and I think, and I understand that opinion.
Do you agree with it?
I think that it was one available option.
Right.
Okay. To make that decision to protect the stair only was a valid. I understand it as a valid design choice.
Yeah.
But the matter remains about the lobby in Grenfell Tower and whether or not it then also requires some form of mitigation. And I've gone on about this in my report at length. So if mitigation couldn't be delivered within the physical constraints of the tower and other constraints, and it was decided actively to protect the stair and explicitly help everyone understand that was the decision that was made, I've been clear that I understand that.
Right.
Yeah.
Yeah. And he says in that paragraph 23 that he's not been able to identify any appropriate smoke control system design capable of installation within the constraints of the tower, which could have explicitly addressed both the lobbies and the stair, maintaining tenable conditions in both at the same time. Now, do you agree with that proposition?
I think that it would be better to do a numerical analysis before saying something that definitive.
Right.
Okay.
Now, if we could go to your supplemental report again, BLARP 25043 at page 217, and I want to look at paragraph 9.2.50, you say, in my opinion, a mechanical extract and natural inlet from a stair lobby depressurisation system could have been a viable option for installation in Grenfell Tower, but only if the designer had decided that the performance objective for the system was to only protect the staircase during the means of escape and firefighting phases and not to protect the lobby by design. Is that right?
Yeah, that's just what I've just...
And then you go on, you say this required an extract capacity and components with the relevant leakage routes factored into the design by PSB, resulting in an increased system performance. Yeah. This was not done by PSB.
Yes.
And the point you've made in this supplemental report, to be clear, is that you say you're not criticising the type of system per se, but you are critical of the quality of the system that PSB installed.
Yeah, it was right? Exactly. It's a perfectly common system type in a suite of options available to designers. Yeah.
Yeah. But just to be clear, if the designers had decided to protect only the staircase, your evidence is it that others in Grenfell Tower needed to be made aware of that?
Yeah, so when you pick that system, it can only protect the stair.
Yeah.
And, you know, and again, just as per my report, etc., as far as I'm concerned, you know, this is this whole thing about the integration and the impact of all the different systems on each other and why you can't design any one system in isolation. And I think that's kind of really, for me anyway, it's really emerged in the really detailed review I've had to do on the system in the last 2 years. But there was a fire strategy for Grenfell Tower. It was an unsprinklered building. It was relying on this stay put condition. And it was in the 1970s stock, you know, it had all the characteristics of that time frame, and it was important to consider what it meant if one took the active decision to not protect the lobby by means of smoke control. That meant someone had to take responsibility for mitigating, you know, understanding any potential hazard in the lobby and mitigating it by a different way. And that is very much part of the duty of a fire engineer when writing their fire strategy. And then PSB can come along and they understand, for the particular building they're being asked to work on, the parameters that they're operating within. Okay, and I'm used to, you know, it's a reasonable expectation. In my opinion, they had every right to expect those parameters to be clearly set out for this specific building and to know, therefore, what their system needed to do when it was integrated in with everything else in the building. It can't just operate in isolation.
Yeah. And is what you're describing the work that you would have expected a fire engineer to have done before PSB became involved?
Absolutely. And that's how it does work. I'm sure Mr. Lay made this clear as well yesterday. Any company like PSB can then take the fire strategy, understand the life safety purpose of the specific system needed in the building, and then can make, you know, as far as I'm concerned, give more valuable advice about which particular system type is relevant for the building.
Yeah. And have you seen any evidence that work was done before PSB got involved?
No, I didn't. And we discussed all of that. I can't even remember what module now, when we were going through Exova.
Yeah.
Okay. And that's why... Anyway, yeah.
And I'm going to come to a few more detailed questions about travel distances in just a moment. But just picking up on you now, you say that there might have been mitigation that could have been provided to the lobbies, given that you say there were these extended travel distances.
Yeah.
Can you just give us an example of, in practice, what could actually be done somewhere like Grenfell Tower to mitigate an extended travel distance if it existed?
So this is then where the other systems come into play. And where one design becomes even more reliant on some other active or passive measure. So if you decided that you could not mitigate travel distance at Grenfell Tower, or that you did not need to with the smoke control system, as far as I'm concerned, my professional opinion is that the performance of the fire doors and the performance of the dampers in the lobby, so the protective devices in the lobby, become even more important, okay, than they are, because you're relying on them more than maybe when you're designing a smoke control system. So the fire strategy and the documentation handed over to the responsible person, it would be really explicit. The smoke control system in this building is there for the following purposes, and it is critical that fire doors and dampers are maintained to the relevant standard.
Would it ever?
And
sorry.
I don't know what I would have done on Grenfell Tower, and it's a horrible question to ask anybody, but I think that I would have been prepared to contemplate something like that, yes.
And I appreciate you might flag that maintenance duties need to be taken especially seriously. That's one example you've given.
But the damper performance,
Yes.
Fire performance in itself and the maintenance of them, all of these things are interrelated. And then if the fire engineer is relying on a system from PSB, where it's absolutely essential, the fire doors have X performance and the dampers have Y performance, all of that needs to be explained.
And would you ever have a situation where you would deliberately increase the level of performance you expect from a fire door or from a damper as a mitigation measure?
Yeah, I don't want to speculate on that at the moment. That's kind of a live design query.
Right.
I think just sitting here today and having thought about it for a while, I think just even acknowledging the importance of those two life safety systems in itself is a mitigation. I'd have to really seriously think and probably do some further analysis for an unsprinklered building about if I needed the standard to go up. But I haven't drawn that in here.
And is that because what you're saying is those who are managing and maintaining the building would need to have that drawn specifically to their attention, so that they were ensuring that they gave priority to the maintenance of those components?
Yeah, and that's this whole thing about doing things knowingly that I've been trying to explain today. That's why you have to explain it. So, I don't have an obsession with documentation. I do have an obsession with explaining to people really clearly what is in their building and what it relies on, and so their role in making sure it can be relied on when the fire occurs. Okay,
thank you. Now, on extended travel distances, some more detailed questions now. If we can go to your Module 3 report, BLARP 2, 5036, and I want to look at page 25. You say at paragraphs 10, 13, 3, you say this, the mechanical extract only system, as it's described in the SCA guide, is a pressure differential system. As a pressure differential must be maintained by the system in operation. And then you go on, mechanical extract only systems are agreed to be inappropriate for the protective purpose of means of escape. And then you refer to your table above. No consideration was given to this during the Grenfell Tower primary refurbishment. And then if we look at the last row of table 5.5 that you refer to there on page 153.
Yeah.
There, in this table with the SCA guide requirements, under 6.4, you've quoted from the SCA guide where it says, it's in the middle column, mechanical extract only systems using natural leakage replacement air are not suitable where extended travel distances occur unless specific consideration of the risks is undertaken by the designer and approval obtained from the authority having jurisdiction. And in the final column, you say, I found no evidence that PSB considered the effect of an extended travel distance on their design, or that they considered how a mechanical extract system using natural leakage may not be suitable for such an application. Now, has your view on that changed at all, having heard the oral evidence and the evidence of Mr. Lay yesterday?
No.
Help us with this. If the designers had acknowledged the travel distances and acknowledged that they were extended, but said that they were still satisfied that the solution was appropriate given the relatively limited additional distance that involved, and given that the primary objective was protecting the stair, would that, in your view, have been a reasonable approach?
If the designer had, go through
So
this.
if the designers had, say, if PSB had put in a paragraph in their technical submission acknowledging the travel distances, that they were in excess of 7.5 metres, but said explicitly, we're still satisfied that this is appropriate given the relatively limited additional distance and given that the primary objective is protecting the stair, would that have been reasonable?
The primary objective for them is protecting the stair.
Yes, of their system.
Okay. So I think that Exova should have written down whether the travel distance required a mitigation or not, and directed PSB to considering. I would imagine there should have been some kind of discussion, and they did actually have discussions, as I remember. Then, when they understood a lobby depressurisation system was, let's say, the best option within the constraints for the tower, that they would describe I'll call it the consequences of relying on that system in the full context of the fire safety strategy for the tower.
Right.
Okay. And for PSB, I would expect them, they do this a lot. If that information wasn't available, they needed to find out what what scope they were being asked to offer a system in.
Right.
Okay.
Now, if we go within your supplemental report to where we see some measurements of the travel distances, this is BLARP 25043, page 269.
Yeah.
Now, this is where you set out your measurements of the various travel distances, and on page 271, it's on from this, we get the measurements at levels 4 to 23. And what we have is your measurement on the left-hand side, where we can see going from flat 4, we get a measurement of 10.3?
Yeah.
10.3.
Bit blurry.
And you can see the path by which you've measured it.
Yeah.
And then we've got Mr. Lay's measurement on the right-hand side, where he's got a path of 9.5.
Yeah.
And it's also recorded that the BRE in their on-site investigation of Grenfell Tower on the far right recorded that it was 9.3, I think, there.
Yeah.
Now, you present this in your diagram, just going back to your diagram, over an architect's plan of the floor.
Yeah,
does that mean that you...
Sorry, is it possible to just go back over, please?
Yeah, I'm so sorry.
See it.
If we could just go back to the left-hand diagram, which is your diagram.
Yeah.
This appears to be a Studio E drawing, so it's an architect's drawing that you've put these distances on. Does that mean that you've calculated the distances from the plan, or did you ever measure them yourself on site?
Oh, God, I can't remember. I don't think I measured them on site. I can't remember. I'd have to go back in and look at my report.
Yeah.
This is from my phase 1 report, and just that's how I measured it. At the time, I was thinking about the shortest distance from flat 1 to the stair because of some very complicated events that happened in some of the flat 1s. And also, I wasn't putting a massive effort into finding the shortest route possible from the furthest away flat, because the cut-off point for me was 7.5 metres. Right.
Do you accept that you could measure it instead in the way that Mr. Lay has measured it?
I'm sure I could get it right down there if I made a big effort.
Right.
Yeah.
But do you consider that there's any guidance which tells you exactly how you should be measuring these travel distances, which is helpful as to whether you do it your way, which has perhaps got slightly more right angles and more straight lines, or whether you cut corners a little bit more? Is there any guidance out there that tells you how to do this?
Not in Britain, yeah.
Right. And insofar as there's a difference between what the BRE's measured and Mr. Lay's measured and your measurement, to what extent does this make any difference to the conclusions that you reach about the importance of highlighting the extended travel distances and addressing that, as we've just been discussing.
What difference?
So does it make any difference that the travel distance might be 9.3 or 9.5 metres to what you've said in your report?
Well, look, the cut-off point is 7.5, and the longer you have to travel above 7.5, apparently the greater the hazard. I'm absolutely clear. Mr. Lake helped. I think it's a few seconds extra just in pure walking time. Absolutely clear on all of that. It's nothing like having to walk, 50 metres or something.
Right.
Yeah.
But do you consider that difference makes any difference to the criticisms you've made of the failure by the fire engineer and the designers to give explicit consideration to the travel distances in their analysis at Grenfell Tower?
They are in excess of 7.5, and it merits consideration. I think people see that as some, really a far more extensive point or criticism than certainly is in my mind. They're in excess of 7.5. It's quite a simple matter to explain what that means, if it poses a hazard or not, and how to mitigate it. And I think it was actually a very simple thing to do at Grenfell Tower.
Right. And can you explain why you think that was a simple thing to do at Grenfell Tower?
Well, it's as we discussed earlier. I've said to you that if the fire engineer had explained they had taken the decision that protecting the stair only was the best course of action, and had noted that there was an extended travel distance depending on how you measured it, I can't see the one over on the right-hand side, between 2 to under 3 metres in extension, and this was their advice about whether that required mitigation or not, the matter would have been resolved.
Right, okay, thank you. Do you consider that the LGA Guide 2011 on fire safety and purpose-built blocks of flats provided relevant guidance for the consideration of travel distances in existing buildings at the time that the smoke control system in Grenfell Tower was being considered by the design team?
Did it consider relevant? What do you mean? Well, it's for the purposes of carrying out a fire risk assessment, and then it comes down to, as someone with duties to discharge and design, if you find the advice within that guidance adequate or not.
Right. And is it right, I want to try and summarise the view you've put forward in your supplemental report. You say in your supplemental report that the LGA guide is not intended to provide guidance for those seeking to comply with the building regulations, as distinct from, say, the RRO or the Housing Act, and that in itself, it contains warnings about smoke dispersal systems which should have been heeded before relying on that guidance. Is that an accurate summary of your view?
No, I've said that, what I've been trying to communicate is that, I don't consider it to be relevant to the building regulations. I understand it exists, and if one is deciding to read it and rely on it now, after the fire, because it didn't happen at the time of this project work, then one has to take full consideration of what's in the LGA guide, not pick out the one section which recommends certain travel distances.
Right.
So I don't agree that it was relevant at the time, and I don't agree that it's relevant now. But if a person takes the decision to rely upon it, I think the least they could do is rely upon it in full. I don't agree that it's right in the first place.
Okay, thank you. Now, a point that was made by Mr. Lay yesterday, and it's a point that's made in the LGA guide itself, is that the 7.5 maximum travel distance that we see in ADB and we see in BS 9991 was never intended to be a hard and fast rule that the moment you're 7.6 metres and you're just a little bit above that, then you've got to have a radically different approach. Now, do you agree with that?
So, I don't think we'd be in this inquiry actually if people were taking hard stops at the end of some of the rules in the approved document. I think it is a measured approach, but it has to be in the round. So you can't, like I've heard lots of the witnesses talk about the travel distance wasn't long enough to worry about. In their minds, they're doing a little mini risk assessment and deciding it's a hazard that doesn't matter. But if you're doing that in every single independent system as you go and never putting it all back together again, okay, that's where the problem starts. So I'm not going to sit here and say that only for a 1 metre travel distance, a Grenfell Tower, etc., etc. In fact, I was really explicit ever since phase 1 that the extended travel distance doesn't seem to have posed a problem at level 4. That I have written that down. Sorry, I'm kind of going off on a bit of a tangent. So I understand that one can think about those rules, but in the round taken together, your duty is to assess the final hazard, the intrinsic risk at the end, and satisfy yourself that taken together, the fire safety strategy can meet the functional requirements.
Yeah. And when you're looking at those travel distances, do you assume that someone is passing through smoke? Is that an assumption you make when you're considering the travel distance and how excessive it is? Do you assume that the lobby might be smoke-filled?
Oh, well, right. Yes, since you think about different scenarios.
Right.
Yeah.
Mr. Lay has pointed out that the way you've calculated your travel distance, if you go to the left-hand side diagram again, might be more appropriate to buildings like theatres or stadium, where there's fixed seating and occupants are walking along a centre line of seatways or gangways. Now, what's your response to that? Is that right? Is it reasonable to assume that someone would walk a centre line, or wouldn't they, in fact, often, if they know the building, take a cut of a corner?
Yeah. So, as I said, I measured this in phase 1. I was actually mostly interested in the shortest distance, as I said. I didn't spend any time trying to find the absolute shortest walking route for a person, because that's not what I was thinking when I measured my travel distance. Okay?
Now,
I absolutely could find the shortest possible line. In fact, I give it a good go to get it under Mr. Lay's measurement, but I don't really think that's the whole principle behind thinking about the hazard to people when they're making their way from a flat door to a stair door in different fire scenarios.
and should one assume that you might have some people doing that who aren't familiar with the building, so new occupants or visitors? Is that something that you might think about? Because
doing what?
so Mr. Lay make the point in his report that for most of the people at Grenfell Tower, this lobby will be very familiar. So it's a familiar travel. It's a lobby they're very familiar with. They'll have travelled it many times. And that's relevant when you're looking at whether travel distances are excessive or not, or too excessive. Do you agree with that?
I think that's a highly sophisticated set of reasoning attributed to a simple line drawn on a plan.
Okay. Now, just thinking about the LGA guide, I've just got a few more questions on this before we move on. Do you agree that whether or not this guidance was relevant to the tower, it might evidence industry practice regarding consideration of travel distances in existing buildings and when they were considered excessive?
Yeah, so first of all, the LGA guide wasn't used by any party when they were thinking about the fire safety strategy for Grenfell Tower. So it didn't happen, okay? And the LGA guide, I mean, I haven't really wanted to give a big, massive opinion on my overall impression of the LGA guide. I gave evidence in a previous module about it. It may reflect some industry opinion, but it doesn't necessarily reflect all industry opinion.
Okay, thank you. In her oral evidence, when she gave evidence, Ms Menzies said this: had I been looking at it, I wouldn't have raised the matter of extended travel distances being a criteria which they would now have to address under the new proposals, the refurbishment proposals. Now, I appreciate she's looking at it from a building control perspective, so that may be a difference, but do you agree with her that it's likely that many reasonable building control bodies wouldn't have expected these extended travel distances to have been raised at Grenfell Tower, or require that to be a criteria which was addressed?
Yeah. I'm not sure Miss Menzies said she wouldn't expect anyone not to notice. She said she wouldn't have expected at that distance, as I understand it. It required mitigation from the smoke control system. Okay? And if she, it's not for me to, I've read what she said. I think a simple acknowledgement and an explanation about how one's going to mitigate the travel distance, or one has just satisfied oneself that one does not need to, is sufficient. I understand that people do a little mini risk assessment in their head and decide it doesn't merit a mention. I understand that people do that.
But is that reasonably acceptable practice to do that?
Why would you not acknowledge it? That's the thing I don't understand.
What you mean? Why would you not?
Why would one not simply just acknowledge it? Because it's a fact.
And would acknowledging it have satisfied reasonably acceptable practice? Just acknowledging the distance.
I think it would show a proper understand. It would show an understanding of Grenfell Tower, and that due consideration was being made to all the different aspects of it that needed to be protected or not in the event of a fire. But I think my reading of all the different reports and the commentary on my work is people have decided that I think this is the deal breaker here, and that is not what I think. Okay?
Now, I want to ask you some more detailed questions about the system as it was designed, but starting with documentation for a moment. Now, in your main Module 3 report, you set out your comparison of PSB's technical submissions against, for example, the relevant SCA guide requirements for documentation. You do that just to help you with this. It's at BLARP 25035, page 148. If we could just bring that up. And this is at table 5.4, where you're looking at the SCA guide 2012 and 2015, and you've got the information that ought to be included. And for example, 2 lines down, it's got the design criteria and performance objectives of the analysis, the scenarios investigated, details of the techniques used and related information, the results of the analysis, and a statement as to whether the design criteria and objectives have been met.
Yeah.
Now, does that remain your view that the documentation that was prepared in relation to this system was inadequate based on relevant guidance at the time?
Yes.
Now, in terms of design considerations, was the failure just in terms of documentation and producing documents to evidence the design? Or, in your view, does it go further than that? And do you have substantive concerns about the design?
Oh, sorry. Yeah, yes. And as explained in my report, yes.
Now, Ms Menzies concluded at paragraph 25 of her supplementary report for the transcript, the reference is BMER 607 at page 7, that PSB's design for the smoke control system, which was conditionally accepted by building control, was a performance-based design for the lobby control system, which was acceptable in principle, but subject to proof that the system worked as intended. Now, do you agree with Ms Menzies about that it was, in principle, it was an acceptable system?
So I think, so I understand what Ms Menzies meant was the parameters were familiar to her, and the concept of a lobby depressurization is familiar, and on that, very high level basis, yes, that is acceptable.
Okay.
Okay, I don't. Yeah.
Okay. No,
I don't know that.
That's helpful. Now, in his second witness statement, Mr Marnie said that he considered the 2 metres per second criterion for airflow across the stair door was appropriate, because although the system was not intended to operate in the same way as a Class B pressure differential system in accordance with the relevant British standard for that, the airflow the system was itself required to generate across the stair door in the circumstances set out in his submission was similar to that aspect of a Class B pressure pressure differential system. Now, in your view, was the 2 metres per second airflow rate an appropriate performance criteria to provide reasonable protection to the stair?
So it's a common number and a common performance objective, and there's no dispute that it was an unusual number or the wrong number. The issue is about when it's provided.
Yeah.
At Grenfell Tower.
And I think
so it's perfectly familiar. You'll see it in all my reports too.
Yes, and I think what you then go on to point out in your report is that if you go to the SCA guides, it provides recommendations regarding the need to consider different scenarios during both means of escape and firefighting, which any properly designed system ought to anticipate and address. Is that correct?
Yes.
And is that because any such system needs to address what the foreseeable scenarios will be when the system is operating as intended?
Yes.
And you, in your reports, you've drawn attention to the fact that both the 2012 and 2015 SCA guides provide some indicative examples of design conditions, including consideration of the stair and flat entrance doors opening at different times for different durations during escape and firefighting, respectively. Is that right?
Yes.
Can we just look at an example of a typical timeline for a time-dependent design? This is in the 2012 SCA guide. It's at LFB 30592441. And if we go to page 13 of this 2012 guide, here we can see a typical timeline for time-dependent design. And if we could have the whole of that table up. And you draw attention in particular, I think, to the last 4 boxes of this table. Is that right? Where what we see is you could have a situation where the apartment window breaks, the door to the stair opens, fire service arrival and remains open, the door to the fire dwelling opens, fire service inspection, and the door to the fire dwelling opens, fire service arrival. Is that right?
Yep.
And does that mean that it's a foreseeable scenario that you're going to have both the stair door and the flat door open at the same time?
Yes.
As part of firefighting activities?
Yes.
And I think we don't need to go to it. There's a similar table in the 2015 SCA guide. Now, you've said in your report that you can't identify any time period in the early stages of the Grenfell Tower fire where only the stair door was open as per the system's design condition, i.e. it was designed to achieve 2 metres per second with just the stair door open. Is that right?
Well, I gave a more nuanced actually description than that.
I'm sorry, have I lost something in that general
Yeah, well,
summary?
you said ever. Or some word like that, sorry, I might have just heard that. So I said, in my analysis of the door openings at level 4, which is in section 12 somewhere.
Yes.
I've explained the door opening and closing scenario.
Yes.
For the first period.
And is it your view that designing a system with just one single stair door being open, with all other doors being closed, was an unrealistic design assumption to make?
In the context of trying to, when you've taken all your decision about your components and everything else, and you've worked out how to produce an airflow through the open stair door, anything that weakens that or causes it to reduce means that you can't meet your offered design target.
Right.
Yeah. So it's common to understand classic leakage routes when when they impact a system like this.
And let's look at section 7 of your supplemental report. It's at BLARP 25043, page 156. I just want to look at what you say at paragraph 7.1.1 onwards. So you say this: once the performance objectives have been set for a mechanical smoke ventilation system, work on the technical specification can begin. The sizing of the components as well as their fire performance are, in very basic terms, the means by which the smoke ventilation system can meet its performance objectives. Yeah. Extract rates, airflow rates, leakage areas and pressure are the primary parameters governing the selection of the system's components. The Chartered Institute of Building Services Engineers, CIBSE, the CIBSE Guide and BS 5588 1998, Fire Precautions in the Design, Construction and Use of Buildings, Code of Practice for Smoke Control Using Pressure Differentials, show the significance of inherent leakage paths. International guidance such as NFPA 92 and other handbooks, etc., also explain the methods of calculation for leakage paths. These range from gaps around doors to more significant leakage paths from protected spaces to the exterior of a building via open doors and windows. Methodologies for calculating leakage are provided at length in these publications also. The extract fan performance, the required airflow accounting for leakage and the associated pressure drop in the system, then guides the selection of a fan of appropriate capacity for the building. The mechanical engineer includes estimates for leakage, frictional losses, and component losses in the calculations for the specification of the fans and other system components. So that's your introduction to why, am I right, to why you say it matters that you need to do these calculations to ensure that you've taken all of this into account in your selection, for example, of your fan. Yes. Is that right? Now, Mr. Lay, in his supplemental report, has, if you go, actually it's conveniently set out at page 157 in this report. If you go to 7114, you can see you've quoted him. And what he says is this. He says, Dr. Lane has also been critical in her Phase 2 smoke control report of the absence of calculations considering the potential impact on the system from doors to flats on the fire floor, including the fire flat being open at the same time as the stair door. Such criticism is, however, not substantiated by an explanation or analysis of the competing resistance pathways that would occur. I have included in part 2 some basic flow pathway calculations which confirm that flow from the stair should remain the path of least resistance even when a flat front door is open. A similar point was expressed by Mr. Marnie in his oral evidence on, and then he gives the transcript reference. So, pausing there, what Mr. Lay's done is he's retrospectively carried out calculations to consider the extent to which the flow through the stair might be compromised by leakage paths, including open flat doors and open windows out to fresh air. And you say in the paragraph 7116 below this, you say these equations do not support the concept of one path of least resistance, and Mr. Lay's use of this term has the potential to mislead. Mr. Lay's path of least resistance argument omits that the airflow through the open stair door will always be reduced for this system type when other leakage paths are available. Now, just to be clear, what exactly do you understand Mr. Lay to mean when he refers to the flow to the stairs being the path of least resistance when the stair and the flat door are open?
That it's preferential somehow.
Right.
Always.
That there's more flow going through the stair than there is the flat door?
Always, yeah.
Is that path of least resistance a technical term that is defined anywhere in relevant standards or guidance documents? Is it a concept that you've come across?
I dealt with that in my report, if you want to turn to it.
Yeah, can you just summarise whether that's a concept that you're familiar with from your work?
I'm familiar with it, and I don't agree with Mr. Lay's wording there, as I've explained in my report. Yeah.
Do you consider that it's a relevant consideration when assessing the performance potential of the system at Grenfell Tower?
How do you mean?
So is it relevant to ask yourself which is the preferential path?
Well, you're trying to work it. That's the whole point of doing a leakage calc. You're trying to work out where the leakage paths are, and therefore where the what's it called? Sorry, path of least resistance is.
Right.
So, I mean, if one wanted to use that term.
So is it a fair summary of your position that what you're saying is the key issue here is about the size of the leakage paths of spaces and how you calculate those, and essentially that if various doors and windows are open, then this will impact on the system's ability to generate airflow through the stair. Yeah. And what you need to do is calculate what you've lost. Is that correct?
That's correct, yeah.
Now, let's just look in more detail at the calculations you've carried out. If we can go within this report to page 163 and look at paragraph 7.4.11. So what you've done is you've taken Mr. Lay's calculations. They're set out in that table at the top. So we see what he's allowed. He's allowed for 3 different scenarios with different sizes, in particular of kitchen doors and flat doors, according to whether they're open or closed, etc. And at 7.4.14, what you've done, I think, is you've back calculated from the calculations Mr. Lay's done, and you think that actually the stair door should be 2.07 metres squared, when actually he's only allowed for 1.68 metres squared.
I thought it was the other way around.
If you go, if we go to 7.4.14.
So I can't see.
You say Mr. Lay appears to have overestimated the size of the door to the stair and overestimated the potential airflow through this leakage path. Now, the point Mr. Lay said yesterday is that even if you correct that, it makes very little difference.
That's correct.
Do you accept that?
Yes, I do.
Right.
Yeah.
So that's a very minor point. Is that fair?
It has a minor impact on the result.
Right.
Yeah.
And then is it right that what you've done, if you go to the next page, figure 7.4, is you've explained in diagram form Mr. Lay's 3 cases. So, and you've scaled the relative openings for us in this diagram. Is that right?
Well,
so we can see.
Yeah, it's a visualization.
Yeah. And so we can see the point I just made, that for some of the scenarios you've got a partial door closure, for others you've got open doors.
Yeah, I was just trying to understand it for myself.
Yeah, and you've got a consistent sized window opening in his scenarios, is that right?
I prefer to see the numbers because this is just a visualisation, but be better to look at the table.
Yeah.
Yeah.
And I think we can see it if we go to page 160 of this report, and I don't think there's any dispute about the methodology between you and Mr. Lay, that effectively what you have to do in calculating these leakage paths is calculate some of them in series and some in parallel, depending on the nature of the space you're dealing with. Is that right?
Yeah.
And if you go over the page, I think Mr. Lay said there was a helpful illustration of that calculation at figure 7.2 here. So for the flat, you have to take the openings in series to work out what you're getting in terms of leakage through the flat door. You do the same for the stair door, because you've got a permanent open roof vent and then the stair door. But then in order to look at the total effective leakage area to the lobby, you then take those in parallel.
Yeah.
And then effectively you calculate that the majority leakage is still the stair door, but there's also some leakage from the flat door. And if we could go to figure 7.6 at page 168 of this report, what you've done here is you've come up with some other scenarios. Is that correct?
Yeah.
Where you provided your own calculations of the effective leakage area with some different openings assumed. Is that right? Now, how did you decide on those 3 scenarios? Can you help us? You've chosen 3 slightly different ones to Mr. Lay.
Yeah, so I looked at 1.35 metres squared is the kitchen window, and in the chairman's report, I think it was heard to break it. I think it was about 115.23. This is all marked up in my report. Do you want to show the image?
Yes, I think if you go to table 7.2 at page 160.
Yeah, is a smaller portion of the kitchen window, and then the not applicable is where I've worked out the area of window beyond which it has no further effect.
Yes. And if we can go to table 7.4 at page 170, this table sets out your calculations versus Mr. Lay's calculations. Is that correct?
Yes.
And what we can see is that the percentage flow from the leakage path Mr. Lay has his calculations there at the bottom.
Yeah.
So for his 3 scenarios, the percentage flow from the flat reduces by 21%, 9%, 7%. But for your 3 scenarios, you've got them decreasing by 21%, 49%, 55%. Yes?
Well, not decreasing.
Sorry,
Right.
not
Yeah,
decreasing, but the
okay,
percentage
understood.
flow
Yeah,
from the
different
flat.
percentage.
Sorry, different percentages,
Leakage, yeah.
higher percentages of
Yeah.
flow from the flat front entrance door leakage path compared with the stair
Yeah.
leakage path. Is that a better way of saying it?
Yeah.
Yeah. Now, one of the queries that's been made
Yeah.
is whether you're assuming that the whole of the kitchen wall in your 3rd scenario is missing.
The whole of the kitchen wall.
Yeah, if you look
No.
at page 169,
No. Okay.
where we've got your, this is a good
yeah.
illustration.
No.
So if we can look at figure 7.6 at the bottom of this
Yeah.
page.
Yeah.
Here you've got Mr. Lay's 3 cases on
Yeah.
the right
Yeah.
in visual form and your 3 cases on the left. And we
Yeah.
can see, for example, that all your doors are open. You haven't got any partially closed doors.
Yeah.
You've got a bigger window in case 1, a much smaller window even than him in case 2.
Yeah.
And then in case 3, it looks like the whole wall has gone, not just the window.
Yeah.
Now, is that right? Is that the calculation you've done to assume
No.
that the entire wall is missing?
No.
Well, can you explain your case 3 then for us?
Yeah. So it's just poor visualization. As I said, I calculated. We'll have to go back to. Do you want to show the equation of the paths in series, please?
Yes. So you find that.
You showed it to me there.
Yes. Sorry, I'm just
Or
trying to
even
find
just
it in
the
my
picture
notes.
just before I say what I'm going to say might help.
I think it's at page 164.
Yeah.
Sorry, no, it's earlier than that. 160.
Yeah. You know that image. Was it not 7 point? Yeah. Here.
16. Is it that? Is that one okay?
Is that
that?
the one in series? Yeah. So
So if we blow up the bottom half of that.
yeah. So if you take A1 as the flat entrance door, A2 as the kitchen doors, I've done, and then A3 as the area of window that's broken, because it's a 1 over the square of a number, 1 over A squared, it eventually becomes an asymptote. I don't know if you're familiar with this, and I am a bit embarrassed saying this out loud actually. It becomes asymptotic, I don't even know if that's the right phrase, and beyond 4 meters squared, it has no further effect on AE.
Right.
And I'm happy to, I can just give you my spreadsheet of it. Everyone can interrogate it for themselves. But beyond 4 meters squared, no matter what you put in that 3rd term, ultimately it has an almost minuscule effect on AE.
Right.
Okay, so it's a numerical thing, and so it should look like 4 meters squared and beyond. It's not meant to be the whole wall is gone.
Right.
Okay.
And where did the 4 meter squared come from? Is that the largest?
That's the
portion of
number
window?
when you plot out the window changing from 0 up to whatever, you see the graph turn, and that's how you know.
I see. So what you're saying is 4 meter squared is the point at which it doesn't matter how much bigger the window.
And in the old days, because I'm an old lady, when I had to get approval for leakage paths, instead of arguing or trying to convince someone, I promise you this tiny piece of glass only will break in the event of a fire, you would instead agree a leakage path based on the number beyond which it had no other effect. That was the easiest thing to agree. And that's what I used to do in the old days.
And if we can go to figure 7.6 again, I think it's at page 168. Sorry, 169 maybe. Yes, that figure again.
Yeah.
Can you just explain why you consider that your 3 scenarios are scenarios that also are reasonable scenarios to take into account in terms of the performance of this system?
Yeah, so I mean, I was trying to, explain why leakage through an open flat door and a broken window matters. And then I was trying to show that the smaller the quantum of glass, say at the kitchen or on the external wall, the smaller it is, the less contribution that leakage path makes. I was trying to show the range of change it has on the leakage path through the flat door. And as I said, I mean, the big yellow box, it doesn't really help understanding the 1 over a number squared situation. But I picked, case 1 is the window as it broke in the kitchen. You can see that in my report. That's the area that was broke. I think it's 115 in the chairman's report. Case 2 is that small piece of glass that's marked up in my report from the start of the fire. And then the point I'm making here for case 3 is that from 4 metre squared on, it doesn't matter.
Yeah.
What the area of the window is, but where you choose a very small number for that 3rd term in the equation, obviously it has a much bigger effect.
Yeah. If we could look at page 166 and figure 7.5, where we see some of the markings up. Of the window.
Yeah, great, thank you. Yeah.
So I think this is what you wanted to look at.
Yeah, just to try and show that they bore some resemblance to the kitchen. But remember, as a designer, you don't know where the fire is going to start. You don't know if it will be beside one particular window or the other. And you certainly shouldn't be trying to guarantee some kind of, impossible to promise quantum of glazing.
Yes.
And that's why I was trying to explain about this asymptotic condition. It's the safest route to take as a designer. And with obviously some argument about obviously the doors, and if you want them open at a little slit, or if you're prepared to accept that there are reasonable cases where those doors are held fully open.
Yeah. Is it your evidence that a reasonably competent designer of these systems ought to be looking at a best case through to a worst case scenario, as you've done in your 3 cases?
Yeah, and I think, Mr. Lay touched on this as well yesterday. So there's best and worst cases when you're looking at airflow. And then, as he explained yesterday, there is also best and worst cases when you want to look at the fire and the quantum of products it produces out in the lobby, depending on the type of system you're designing. So it isn't just you have scenarios and you resolve them for leakage. Sometimes there's other scenarios for different reasons you also have to take due account of. But for this system, these are the most important scenarios.
Thank you.
Yeah.
Now, if we go to figure 7.7 of your supplemental report, so staying with this report, page 172, what you've done in 173, I beg your pardon. What you've done in this diagram, 7.7, is you've plotted the levels on the left-hand side and the velocity at the bottom.
Yeah.
And then we've got the 2 metres per second line identified in red. Yeah. And you've plotted onto this the different velocities, assuming certain things. Now, the grey line is actually what was measured during commissioning.
So the grey line, yeah, so it's very important we are clear on this. Each grey line is the product of a particular measurement on some unknown date not an unknown date, in a particular set of circumstances, floor by floor by floor. Yeah, and that's the only commissioning data that I have available to me. Yeah, I think I've said the same thing as you. Sorry, I wasn't meaning to distract.
No, that's fine.
Yeah.
And then we've got in orange we've got effectively one of Mr. Lay's cases, which is a flat door opening of 1.75, a kitchen door opening of 1.5, and a window opening of 0.25.
Yeah, they're my three cases actually, because Mr. Lay doesn't. He has to, I think, from memory. Because I prefer to see the table. His door is much.
Yes.
The kitchen's much smaller as well, I think.
Yeah, and then we've got your worst case scenario, which is the yellow.
Yeah.
Which is assuming just a stair door velocity and a flat door opening and a kitchen.
And then the condition.
The 4 metres.
Yes.
Yeah, which is the maximum beyond which it doesn't matter. Yeah, I see. Now, but it's right, and the point's been made, including by Mr. Lay, that, for example, if you look at level 4, even with your worst case scenario, the system is very close to achieving the 2 metres per second.
Yeah. So it shows that when I apply a reduction to the flow rate recorded on that day, it's very close to that value recorded on that day. But that I have I don't agree that this data has been proven to demonstrate the system in its very final condition before it was handed over. But on this graph, yes, it's absolutely correct.
So that's for level 4, but we can see as we go up, there's almost a slight pattern emerging whereby the higher you go up, it's not. So take level 23. It's not achieving conservative estimate.
I don't consider it to be conservative.
Sorry.
Yeah.
Your best case of your 3.
That one of my scenarios. Yeah. And then you can see. Actually, I kind of wish I had presented these separately now, but you can also see the way the flow rates at level 3, in whatever circumstance that level 3 data was obtained, are particularly high, and the change between 4 and up, and then the new floors 3 and down.
Yes.
Okay, so then obviously my percentage reductions just follow that pattern.
Yes, I see.
Yeah.
Yes.
And I suppose I'm bound to have to say that as a designer, I have a duty to get every floor right, not hope that the one floor I may or may not have got right is the floor that the fire started on.
Yes, I see. Now, should PSB have carried out these kind of calculations that you've been referring to?
I'm assuming that they do that all the time.
Have you seen any evidence that these calculations were carried out?
On Grenfell Tower, no.
Now, Mr. Lay said yesterday in his evidence, well, OK, that's looking at the airflow through the stair door, but that's ignoring other positive effects of this system which you've got to take into account, and that includes smoke extraction, smoke dilution, and the flow velocity that you might get across the lobby. So it's oversimplistic just to focus on the 2 metres per second.
Okay.
Now, what's your response to that?
I think that PSB designed a system to produce a flow rate, and I don't know when that flow rate was possible.
And had these calculations been carried out by PSB, and had they got this kind of data, suggesting that with some of the scenarios you're not achieving your 2 metres per second, what would you have expected PSB to have done about that? What's a reasonable response by a designer if you get this kind of data once you've done your calculations?
I don't really know what do you mean.
So, assuming
if they got these answers, or do you mean they did their calcs?
Assume they've done their calculations and they've worked out that for some of the levels, with certain scenarios, you might not get your 2 metres per second.
Yeah, well, they'd have to go back and look at all sorts of different parameters and work out how to.
Yeah, and what would be the top 3 things you would be going then to look at in your system?
Well, it all, at the end of the day, it all comes down to what the performance of your fan is, and we're back to pressure drop, the fan performance, and trying to overcome any resistances, including these leakage paths, so that you can get the right velocity through the stair door. I'm not an expert in twiddling around with the systems I'm not an expert in that. Yeah.
And is one of the reasons you say that your scenarios are more realistic, that's what you would expect during firefighting operations, to have the doors fully open? Because Mr. Lay had some doors that were partially closed, and he made the point, for example, that the kitchen door would close in a certain direction, and that might mean it's less likely to be fully open.
So I understand all of that. So we're applying knowledge of what happened the night of the fire, okay? I'm looking at designing a system when you don't know what's going to happen. You don't have the luxury is a terrible word. You don't have the benefit of knowing what may happen in the event of a fire. You have to design your system so it can do what you're saying it's going to do for a reasonable range of scenarios. And that's how I've gone about this. I understand that Mr. Lay and others are really focused on the night of the fire only, and those parameters and what that might mean. I'm looking at this as a system, and there was a duty to design it and how one goes about doing that. And I think that's a really important distinction. Retrospectively, trying to work out the consequences of that design in the really specific circumstances that we may or may not be able to derive the night of the fire, I see it as two totally different things, actually.
So does it follow that you don't accept that it's acceptable, for example, to look at level 4 here and say, well, we've got almost 4.5 metres per second through the stair door at level 4, and even if we halve that and assume we only get half of that, we're still almost at 2 metres per second. That point's been made by Mr. Lay, and it's been made.
Understood. And actually, one of the main reasons why I did this work was actually because of an exchange the chairman had with Ms. Menzies about this data. And I thought it was an extremely important exchange, because the presumption was this data represents the system, I'm going to call it at the moment of handover, when absolutely everything was finished, everything had been tweaked and balanced, the final set of appropriate cause and effect testing had happened, and there was a moment in time when you go, this is my data. That is the actual purpose of commissioning, by the way, that I could take that data out now and say to you, these grey lines represent the system as I designed it. And we can't say that. If we could, I'd be happy to have a bit of an argument, maybe, if someone was asking me my opinion about the events of the night. I'm giving my opinion on a design and whether or not it met the functional requirements of the building regulations.
Okay.
I hope that's probably a bit rambly, but I think...
Can I look at Mr. Lay's recent statement? It's at LAY 703 at page 14. And I want to read to you what he said at paragraph 70 and 71. He says, in her report, Dr. Lane refers to reports produced by COLT, which relate to the protection of stairs by a smoke control system similar to the system, by which I mean they employed extraction from the lobby with inlet via the stair. As noted in Dr. Lane's report, the COLT reports were relied upon for smoke control system designs in residential buildings. The COLT CFD report states that protection to the stair was achieved when the mass flow rate drawn through the door when their smoke control system design was operating was 1.9 kilograms per second, which for ambient air through a 1.6 metre square single-leaf door opening would equate to a flow velocity of 1 metres per second.
Yeah.
This matches the velocities shown in the computer modelling images in the report. And then he goes on, he says, hence, either a flow velocity significantly less than 2 metres per second alone can prevent smoke movement to a stair, or a lower flow rate in combination with the other mechanisms, extraction and dilution, can achieve a combined effect which results in a lower flow velocity being necessary to protect the stair. My experience suggests that the latter is the case.
Yeah.
So I think what Mr. Lay is saying is that based on a lot of information that others have done, other studies that have been done on similar systems, in fact, as long as you're getting 1 metre per second through the stair door, that's enough, and it's going to give enough protection to the stair. Now,
but what's enough? So the Colt report, actually, I don't have it to hand, and I certainly don't know it off by heart, but there's a reason why it goes on to recommend a higher flow rate. And I think the big difference here, and I don't know that I need to go on about it so much, is Mr. Lay is trying to justify the performance observed on the night of the fire. I'm giving my opinion on the system as it was designed. Okay?
okay.
It is, of course, obvious if you get some kind of flow rate through the stair door, it might do something. But that's, I'm looking at what the design set out to do something, and I'm explaining what I have found about whether or not it actually was designed that way. Okay?
Okay.
I understand, well, actually, this whole thing about what actually happened on the night of the fire is quite dangerous territory to get into, because there's so many parameters that may or may not have impacted that system.
Yes.
That we start to talk about. Surely it gave us 1 metres per second, and that was fine.
Okay.
Okay, but Colt actually went on to increase that parameter, and I'll check their report at lunchtime. Yeah.
Okay. Now, one point I want to put to you is that we know that what Mr. Marnie did was he worked out what he needed the extract rate to be. He said he needed that to be at 3.2 metres per second. And then he added, based on his extensive experience, he added 50% for leakage to be added to that. And that gets you to 4.8. And in fact, the fans were rated to provide 5.6 cubic metres extract. The south fan gave you 2 cubic metres per second, and the north fan at high level gave you 3.6, hence 5.6. Now, why isn't that an appropriate way of doing this? Mr. Marnie's clearly experienced in these systems. He obviously has experience to draw on. Why isn't it acceptable for someone in that position, using that experience, to add on something like 50% for leakage, and then ensure that your fans can give you the airflow that you need that way?
Yeah, but that's leakage innate in the building construction, so I don't know how Mr. Mahoney quantified all the different things that cause resistance in his system. Leakage through the builder's workshops, twists and turns. I don't know how he did that. It's normal to have that set out. When he said he factored it up for leakage, I understand that. I don't know how he satisfied himself that for Grenfell Tower, that was sufficient.
Do you ever think, though, it might be reasonable to rely upon somebody's extensive experience in just instinctively knowing how much leakage you need to allow for with these systems?
But we have to be careful about which leakage we're talking about, okay? Because there's leakage through all different routes. And I don't know if when he factored things up, he had already worked out from his last job that he knew about leakage through a broken window. I haven't seen anything like that. And instinctively knowing how a complicated smoke control, I think you're asking me if that's a reasonable design, reasonable professional behaviour, is it?
Yes, I am.
No, well, I don't think so. I think I've made that perfectly clear. Instinctive. I have all sorts of instincts, and I'd imagine that lots of them end up being terribly wrong. We, as designers, you have these duties under multiple regulations, if nothing else, where the obligation is to demonstrate, this was an existing building with all different characteristics, and one needed to work out if they were being incorporated into the design for the tower. Okay, and I don't know how you do that instinctively.
Okay. Just one final short point before we break. Mr. Lay also said that you might have got your stair vent size wrong, in that you'd assumed 1 metre squared, and he thinks it might be bigger. Is that something that you can respond to. Have you had a look at that?
No, and I won't be looking at it either. No.
Because?
Well, because, I mean, I don't know when we checked that on site, we checked the drawings. I don't know why he's decided it's bigger.
Okay.
And as far as I'm aware, I'm finishing my work today.
Okay, so do you accept that you might have got the stair vent size wrong?
Well, I'm surprised no one's noticed it in the last 5 years. And if he could just mark up, maybe he did this. Did he show a marked up drawing or something?
No, he just said she's assumed 1 metre square and it's bigger.
Well, if he wants to pop along a drawing with the incorrectly measured stair vent onto it, I'll have a quick look at it, no problem.
Okay, thank you. Mr. Chairman, I think that's a good moment for our lunchtime break.
Yes, so do I. Thank you. We'll stop there for lunch. We'll resume at 2 o'clock, please. And again, no discussing your evidence.
Yeah, no problem.
Thank you very much. Thank you, Ms. Grange. 2 o'clock, please. Thank you.